Thank you, Zoom person, for letting me know the meeting's recorded. Well, good evening, everybody. Welcome to Advanced Programming with Java at Portland State University from our homes. I'm David Whitlock. I'm the professor for this course. I've been teaching this course for almost 20 years. It'll be 20 years in September, which is a little hard to believe. They hired me at age 15. Now I can't even lie about my age like that anymore. Um, And of course, the worst thing about doing all this remotely is I can't hear the uproarious laughter that I'm sure would have ensued if we were all in the classroom when I tell my dad jokes. Um, so this is of course all about programming with Java. You're going to be learning about object-oriented programming, unit testing, all sorts of great stuff like that. But this will be a different experience because we're all remote. I've always taught in the classroom, and actually over the last couple of years, I've really leveraged the in-classroom environment for some really interesting learning experiences with mob programming and pair programming. We're going to try that this term with everybody being remote, but I don't know what's going to happen. And I hope there'll be a good result. I've delivered a lot of the content remotely, or at least a lot of it asynchronously before. But without having sort of the same in-class experience, it's going to be a big learning experience for me. I'm sure it'll be a learning experience for you. I'm going to get started here with some slides here in a moment. So I'm going to share my screen. Share, I guess, the entire desktop. See how that works. Cool, I'm sharing my screen. Let me start oh, so many windows. Present. So hey, welcome aboard the Advanced Programming with Java train. So we've got a lot of stuff to cover tonight. It's 5:30 now. The sun is still out. That's nice. But tonight we'll probably go for quite a while. Normally I don't like to go for I don't know, the course is listed to go into like 9:30 at night or something. There might be a couple of nights this term where we go that late. But it's a long haul for everybody, and even longer since we're all remote. Well, here's what we're going to do tonight. I'm going to introduce myself. I'm also going to introduce the graders, the people that will be helping you with the course. We're going to cover the syllabus for the course and the content of the course. Then we're going to move on to create our first Java project. I guess one of the advantages of everybody being remote is that you're in front of a machine. And so then, sometimes in the classroom, not everybody has a laptop to bring with them. Not everybody wants to, be on a machine while trying to listen to me. But for better or for worse, we're all here. And so then this will allow maybe a little different kind of learning experience where it's more, it's part lecture and part lab, and you can play along with home. And if you have any questions, you can get them answered maybe in real time. We'll see how that goes. So we'll create our first Java project. We'll learn about the Java Koans, which is one of the first assignments. We'll also take a look at test-driven development and see how we can apply test-driven development in a Java project. So a lot of stuff to start out with tonight. So I want to introduce myself and the people that will be supporting us this term. So it's me, first of all. I'm David Whitlock. Like I said, I've been with PSU for almost 20 years now, and I during the day I work at Tripwire. I lead up what's called the Agility Enablement team there. We're also involved with PSU through the PSEP program. We're big fans of PSU and its students. And helping me out this term are two graders, Prerna Agarwal. Is one of our graders. She has a lot of experience working as a grader in some of the lower division courses. And Riley Everett is also, Riley Everett is also a grader for us. I'm really excited to have Riley with us. He took my course, I think it was over the winter, and it's really great to have someone who's taken the course. Oh, hey, it's Riley and everything. Do you want to introduce yourself, Riley?
Yeah, sure. Hi, I'm Riley. Yeah, I did take the course over the winter and enjoyed it a great deal. I think you all are in for a real treat. So,
Excellent, thanks. Great. He can laugh at all my jokes. Mute yourself when you want to laugh. You're not going to mute yourself.
no, they're really good jokes, to be
Oh, they're
honest.
not that good. Oh, you've already gotten your grade. You
No,
can't do anything. Maybe you're looking for a little recommendation or something. I don't know.
no, I'm just I'm a fan of dad jokes, and you got
There you
some A+ ones.
go. Oh, thanks. So we're really looking forward to working with you this term. It's the graders are essential to the success of the course and of the students in the course. There's a lot of you. As a matter of fact, I think I talk about that in a future slide, and they're really essential to making sure that you can get feedback on your work in a timely fashion. So I'd be remiss if I didn't call out that this is an unusual offering of advanced programming with Java. The campus is closed, has been since March, and with very good reason, right? We're looking to keep as much of our community healthy as we can by reducing the spread of the COVID-19 virus. And so as a result, all of our interactions in this class will be remote. And so I wanted to highlight some of the ways that we're going to communicate and collaborate this term. So during the class meeting time, we're not going to a classroom, we're not going to campus. All of our the presentations and discussions, the activities that we have during class will occur using Zoom. And so it'll occur during the normal class time. It'll start at 5:30 sharp. I'm experimenting with breakout rooms. I used it a little bit at the end of the last term, and it seemed to work pretty well. I'm a big fan of programming as a team sport, and so I want to make sure that you all have a chance to work together, and breakout rooms work pretty well for that. I'll also host my office hours in Zoom, and they occur an hour before class, so I'll probably just hop on Zoom. I might use the same one. I don't know. I'll figure it out next week. And you can stop by. I don't know exactly how it's going to work in terms of, hey, if you want to show me some code, if there are other people in the room, we'll figure that out. But that's how I'll be working with you sort of face to face in real time. The course actually is it's not too much of an adjustment for me to take the course 100% remote. Luckily, I'm not used to writing on a chalkboard or, gosh, if this was like a science lab or something where you had to do I don't even know how you do a chemistry lab remote, right? Go find some vinegar in your kitchen and maybe some like baking soda and make yourself a volcano or something. I don't know how college science works these days. But anyway, all the lecture materials and when we are, sorry, all sorts of things are popping up and trying to figure out how to use Zoom. Oh, here we go. Oh, good, you guys are emoticoning for thanks. All of the lecture materials and all of the recorded class sessions are available on YouTube. So I'm recording this here in Zoom. I hope the quality is okay. Usually it's pretty good with Zoom. And what I'll do then is I'll upload the video to YouTube. And so this is for, if you were in class and you want to go review something, or like, I know Dave said something about the assignment. What was that? You can go back and find it later. And also, if you can't make a class, I want to make sure that the information that we cover is still available. We're all adults here. We all have lives. A number of us have families and jobs and outside responsibilities and things like that. And I want to make sure that the class is as accessible as I can make it. And so then I will try within 24 hours of class to get the recording up there so that you can review it later. All quizzes and exams will be administered through D2L. I hope you're familiar with that, and that includes the final exam. And so then the final exam will be through D2L. And again, the graders will help me grade those. And then when it comes to sort of day-to-day communication, I like using Slack. Used to use email a long time ago. Email just feels really heavyweight when you just have a quick little question. Or whatever. So I sent everybody an invitation link a while ago. I'll post another one here. Let's see here, it's down here at the bottom. Invite people. Share invite link. Here we go. Expires in 6 days. I'm just gonna post this to the Zoom chat, which probably you already have because you got the Zoom. So maybe I don't need to do this. Thank you to everybody who has registered, who has already signed up for the Slack. This is where I post announcements for the class. This is where when you have a question that you'd like me to answer, or maybe you're running into a problem, you're seeing some stack trace or getting some exception or whatever, posting about it there. It's an opportunity for me to see it, for the graders to see it, but probably most importantly, your fellow students to see it and say, oh yeah, right, I ran into that same problem. Here's why I did it. I found that it's a really effective way to help the class scale and help you get your questions answered in a timely fashion. So we use Slack. Now, like I said, I've teach this course for a long time, and it's gotten really popular. I'm overwhelmed by the response, and this time it was interesting. Normally when I teach the course, we cap the course at 50 because that's how many students the fire marshal will allow in my my favorite room at all of PSU, which is what, Fab 10, which is that room downstairs in the Fab that has the cameras and the whiteboards around the perimeter. I love teaching in that room. It's great for mob programming. And for whatever reason, it's only rated for 50 people. It's a big, huge room. You can only put 50 people in there. But this class registered full pretty quick, and there were long wait lists. And so then I worked with the department head, and I said, well, we're not going to be in a classroom. And so, as long as you'll pay the graders, to grade, enough hours, then I'm happy to teach, whoever wants to enroll. And so we bumped up the enrollment limits nice and high. And so I believe everybody's been able to register who wants to. But right now I think we have over 70 students, which is huge for an upper division computer science elective. So thank you for all of the interest. And we're going to try our best to make sure that you have the best learning experience that you can. But this is a scale that we've never run the class at, and certainly a delivery mechanism that we've never run the class at. We got 57 people here right now. Okay. So, any questions before we dive in? Sort of general things about the class. We still need to get to the syllabus and stuff, but anybody have a question? And actually, if you do have a question, would you mind using the, oh, there isn't a hand raise, is there? Oh yeah, wait, Max just did it. Some people were raising their hand. How'd that happen? How do you do that? Maybe I can't raise my own hand because I'm the host. Anyway.
Participants.
Only participants can? That's kind of smart. Cool. Well, if you have a question, would you please raise your hand in Zoom? I'm trying this out. I'm making it like go along. Nope. No one's got a question. That's fine. Awesome. Okay. Yes, Mark, you have a question. I'll mute you.
Yep. So the question is, Thinking in Java, the 4th edition book, maybe you're getting ready to cover it, but it was referenced. I didn't know if it was mandatory.
It is not. So every year they ask me, do you have a textbook? And I'm like, that's a good book in Java. It's kind of old though. Honestly, this is not the kind of course where it's like, I've got a textbook and I follow it. And, this week read chapter 7. That's just not the way I teach. So I don't have a book. I just haven't written my own book yet. So no, and really any good book on Java, and there's tons of online resources. So, in this day and age, I understand people work, some people learn best from a book. And if so, I don't really, Thinking in Java is what I recommend, but it's not required by any means. Tom?
Yes. For Windows users, is this going to be problematic running some of the scripts like Maven and stuff?
Nope, I have lots of students every year who use Windows. The examples that I'll give are going to be Unix centric. I have a Mac and I grade things on the school's Linux systems. But nope, Java works just fine, as does the Android Studio and Android development environment works just fine on Windows. And I've tried my best to make sure that there are command scripts.cmd scripts for like all the things to create the projects and stuff. They're not as well tested as the Unix ones, we'll say it that way. And so then if you find something, it might not be your fault, it might be mine. But they've been exercised pretty well over the last couple of years. So nope, that should be all right.
Okay, thank you.
Yep. Okay, cool. Okay, awesome. Let's move on to the syllabus. So, oh, awesome, here we are. Okay, this is the course homepage. This is, I try to have all the information in one class and organized by week. There's a lot here. And yeah, it kind of looks like, Alta Vista circa 1997 with all of the words and everything like that. I'm not a web designer. But the main information is here in the middle. So here's all of the stuff for tonight. I'm going to close participants. We'll see if anybody shows up late. We'll start, let's see here. These are some screencasts and slides to get you started. The screencast just is me talking to the slides. The first thing we're going to talk about tonight, though, is the syllabus. So, the goal of this class has always been to learn about more exciting programming stuff than what you learned about in in your first class. Sorry, a question from Daiwei came in. When will Java be used instead of Python for full stack development? Is that specific to the course, or is that sort of a more general question? Daiwei, can you unmute yourself? Yeah.
Yeah, it's more general. Maybe I just like to know that we can do a lot of things in Python right now, but is there any particular scenario where we better to use Java, especially for the full stack development?
This is a pretty big question. I don't want to go into too many details right now. There are differences in the programming languages, and as you're probably aware, in terms of static versus dynamic typing, in terms of performance, and the ability to run there. There are lots of good frameworks in Java. There are lots of good frameworks in Python. There are lots of bad frameworks in Java. Lots of bad frameworks in Python too. And certainly, if you're writing, a web application, you need to figure out what you're going to do on the client. Writing JavaScript or whatever. But honestly, I know Java, and so when I talk about things like hey, how to develop modern, contemporary, good quality software engineering, this course is in Java. So, but my hope is that you'll be able to, you'll learn about Java, you'll exercise, your Java programming skills in this course. But most importantly, what you'll learn is good software development techniques. So we'll be really focusing on, and probably the things that are new to you, will be using APIs, doing good quality object-oriented programming, learning about unit tests, and lots of automation, and the tools that I'm most familiar with are Java, and so the course is in Java. But a lot of it, pretty much everything that you're going to learn here is transferable to other languages and runtime environments and frameworks that are similar to Java.
Thank you.
Yep. Okay. Okay. Thanks, Riley. See you later. And actually, since we're at a pausing point, I think I just saw Prerna join us. Hey, Prerna, how you doing?
I'm doing good. How are you?
Doing all right. Would you mind introducing yourself to the class and tell them a little bit more about yourself?
Sure. Hi, everyone. My name is Prerna. I'm a graduate student at PSU. I just started my master's in spring term, and I did my bachelor's from Portland State as well.
Excellent. Well, we're really happy to have you aboard. And so Riley and Prerna will be tag teaming to grade the quizzes and the projects actually that we'll talk about shortly. Okay. So what are we going to do in this class, and how are we going to do it? So there's a number of ways that we learn together. There's lectures that are online. There's discussions that we have in class. There's pair programming and mob programming. We'll have an opportunity to experience all these different kinds of learning. I'm a big fan of learning by doing, and so there's a lot of examples in this course. You'll see a lot of code. You'll see me writing code. You'll read a lot of the code that I've written. You'll be coding with each other, right? If this is a course in programming, and so what we do is programming. We're not just going to read about it. We're going to apply what we learn. And one of the ways that we're going to apply that is through a multi-phase project. We'll see the first part of that tonight, and what we'll do is we'll build up an application over each week of the course. And hey, it wouldn't be a real college course without quizzes and exams, right? So we got quizzes and exams too. And so then we'll talk about the grades and how all that works a little bit. So what are some of the topics that we're going to cover? And we're going to talk about the Java language. There's lectures on it, but you're also going to see me writing code. We'll talk about object-oriented programming and design, and really how to structure your code, structure your classes and your objects, and how they interact in a way that results in code that's reusable, that's readable by other people, and can be extended to future needs. We'll also be learning about standard APIs. And so then, I think in some of your other classes, you might have experienced a little bit with the standard Python libraries or the standard C++ libraries, all those templates and stuff like that. Here, it's a big focus of the course. So, unfortunately, no, you won't be getting to write your own linked list in Java. You don't have to write a stack. Someone else has done that for you. Someone else that's, probably a little bit more experienced than you and paid a lot more to write like the best Java stack ever. So, you'll be using a lot of other people's code. Now, I think what's really novel and what this makes this an advanced programming course is some of the other stuff that we do just besides learning about Java. So we're going to be learning about how to unit test your programs and how to do test-driven development, where you write a test first that fails, and then you implement code that makes it pass. And we'll see how this has pluses and minuses in terms of writing a good quality code. And we'll also learn how to have an automated build process for your Java projects. Because as your projects get bigger, as your programs do more and more things, rely on third-party libraries, you need to keep track of it all. And we'll be using the Maven tool to help organize, download all the artifacts. It's really good. You'll see it a little bit. Later in the course, and really the second half of the course, things start getting interesting because we'll move beyond building command line applications to building other kinds of applications. The first one will be a web application. So we'll be learning how you can write web applications in Java. Now, this is the back end of a web application. It's a REST API. So you'll be learning about HTTP and something called servlets. You won't be doing front-end JavaScript code in this course. What you will be doing instead, though, is you'll be writing an Android application. And I've always had a user interface part of this course. I hear computer programs have user interfaces now, but yet, very, very often college students aren't exposed to that. And I want to make sure that you have an opportunity to learn about what it takes to program a user interface, because there's some concepts that are very different from the command line, and it's concepts that are used in all sorts of different kinds of programming. Evan, you have a question. Sorry, I just muted you again. Unmute.
Oh.
Sorry.
Yeah, just out of curiosity, is the web application, is that using Spring or Spring Boot?
No, it's using just a plain old servlet API. It's not only just about web programming. It's also you learn a lot about HTTP and so how to do that. So it's kind of low level on purpose. And so then for the web API, we're not really leveraging any frameworks. We're sort of learning about the fundamentals in terms of just using the raw, plain old servlet API. Yeah. Okay, so those are the topics that we're going to cover this course in the course. Okay, let's talk about the grades. That's an important part. It's how you're assessed. The majority of your grade is made up of the project and how it performs. And so there's a multi-phase project. I think it has 5 phases this term. And there's also the Java Koans project, which we'll talk about tonight. And that's built up over the entire term. And that accounts for 60% of your grade. So the vast majority of it is the work that you do every week writing code. There are also 8 quizzes. And I dropped the lowest quiz, and each one of those is worth 3%. Now, the quizzes are online using D2L. And again, I dropped the lowest one in case you're having a bad hair day or you just mess with the quiz. And 2 of the quizzes are surveys. Your feedback is very important to me. I said it's like customer service agent. But those are surveys, and they're often a different part of D2L. So if you're used to looking in the quizzes section, you're not going to find them there. There's also 2 written assignments, I guess, which ask you to talk about your experience with and kind of do a little bit of reflecting on pair programming and mob programming. And so in this course, in weeks 3 and 4, and then 5 and 6, I can't remember, we'll have 2 opportunities to pair program and another 2 opportunities to mob program. And while in general attendance isn't mandatory, you must attend one pair and one mob programming session in order to provide your reflection on it. And those reflections will be presented as a D2L quiz. The final exam, there is one. It's worth 12%. And so then if you look in terms of the weight of the various things in the class, the final exam really isn't worth very much. This isn't a do or die final exam. In this kind of course, it doesn't make sense, and just in general, that's against my philosophy. I want to make sure that the work that you do over the term determines your grade, not just like how much stuff you were able to bang out during the final exam. So that's how your grade's calculated. Some other policies are related to your grade. Now, there's a lot of work in this class, right? I mean, you've got 8 quizzes, you got 5 projects, you got the Koans, you got the reflections. I mean, there's a lot there. And I understand we've all got lives, and hey, it's summer, right? Sometimes you got to make a choice between taking care of yourself, taking care of your family, and getting your homework done. So I understand that, and so then the policy is that you've got 2 late days on project submissions that you can use at your discretion. All the projects are due right before class because on Wednesday nights I want you in class, so please get things done before class starts. But hey, if you aren't able to get it done, you've got 2 late days that you can use over the term. You can also submit one project for regrading within a week of the original grading. I request that the graders do the grading over the weekend, lucky them, and so that you can get your feedback on your quiz feedback on your project by Monday, which means that you'll have until the next Monday to resubmit it. This is in case that maybe there's some fundamental aspect of the assignment that you didn't understand, or you had one bug that caused all the test cases to blow up. Otherwise, my policy is that no other late work will be accepted. With so much work, it's a lot of work on the graders too. It's a lot of work for me to coordinate. So, please don't get behind in the course. It'll be best for everybody. Students always ask about the curve. I reserve the right to grade on a curve if it makes sense to do so, but it usually doesn't. I found that actually, people fit the curve pretty nicely, and I usually, almost always, use the standard grading scheme. So, whatever it is, a 90 and above is an A of some sort or something like that. But depending on how things go, and this term might be exceptional, I might apply a different curve. Question from Andrew Stevenson. I'll unmute you.
Thank you. Yeah, what about partial days on the two days that can be used at our discretion?
I'm not gonna say, oh wait, it's 23 hours or whatever. So no, it's not like a total of 2. So again, so hey, if it's Wednesday afternoon, you got another 8 hours to finish this assignment, not gonna get it in, put it down, come to class, figure that out, then come back the next day when you're fresh and finish it out.
Okay, so that's 2.
That'd be 1 day, right?
Okay.
So if
right.
yeah.
So maximum total of 2, and then maybe possibly 1 if you just take a long time.
Yeah.
Got it. Thank you.
Yep. No problem. Okay. Oh yeah. So and one last thing. There are 2 sections of this course. There's a graduate and an undergraduate course. The material's all the same though. Right. However, I do have 2 grading curves for each of them, or rather, I reserve the right to have 2 grading curves for each of them. But all the policies and all the assignments are the same. I'm not going to try to give harder assignments to graduate students or something like that. Okay. Disclaimer. It's like the lawyers maybe put it in. Don't cheat. Come on. And I'll catch you. I've got this tool called Moz. I've been using for years. It's really good about I set up all the source code that you submit. It puts things side to side. Haven't had a cheating problem in a while, but boy, there were a couple times I did many years ago, and it makes it pretty obvious. It's like, listen, you copy each other's code, and you can rename variables. You can try to be smart. Nope, it's much smarter than you are. So just don't copy other people's code. And just to be clear, the policy is that cheating is submitting for credit work that you did not create or allow your work to be submitted as work from another student. My policy is talk all you want, draw pictures, don't look at each other's project code. You'll actually have a lot of opportunity to look at other people's code through the mob programming, through pair programming, watching me code and everything like that. But when it comes to, other students, resist the urge to quick share the screen, or, send somebody your code in an email, or open up your GitHub repository, or whatever. That's not cool. And if you don't do that, it's probably very unlikely that you're going to end up with the same code as somebody else. Let's see here, lots of miscellaneous notes. The website is the best source of information about things, where the links are off to all of the slides, all of the screencasts. Please come to class prepared. I'm happy to answer questions that you have about, like, hey, I watched the lecture, I didn't understand this concept, or hey, you talked really fast in that section. What do you mean? And I'm happy to do that. But I expect you to have reviewed the slides and or watched the lectures before, so we can talk about these topics. Please don't wait until the last minute to start the projects. So they're harder than, they're more complex than you think, and there's more details. Plus, you got to write unit tests now and stuff like that. So even though it might seem really easy when it's first assigned, start it early. Documentation is part of this course, and next week I'll go into a lot more detail about what I mean by documentation, what the expectations are. Document your code as you write it. Use good variable names, use good method names, put in the appropriate comments. As you're writing it, it'll save you a lot of time afterwards. And please ask questions. I as much as I love to hear myself talk, I'm not here for my own benefit, I'm here for yours. And if there's something that you don't understand, or if there's something that you need more clarification on, or if there's something that's piqued your interest and you want to explore it a little bit more, please speak up. There's no shame in this, and my experience has been is that if one person has a question, you're probably not the only one, and it's the brave student that'll raise their hand and say, "Wait, what are you talking about?" So please ask questions. So this is a senior level course. It's cross-listed as a graduate section. There's a bunch of work, and there's stuff that you haven't done before, like Android programming, which might be exciting, but it's also a lot of work. So if you're taking a lot of other courses with a heavy workload, so if you're also, especially high coding stuff like operating systems or compilers, you want to take a look at your schedule. This course is offered at least once a year. I was lucky enough to have it offered in the winter too. So make sure you're setting yourself up for success and not a bunch of frustration. I want you to enjoy the course. I want you to get a lot out of it. You want to get a lot out of it too. You're paying good money for it. So make sure you're taking the load that's right for you. And like I said before, there's lots of code samples. Go home, play with them, work with them, understand them. It's a great learning tool for the course. Office hours are held an hour before class on Zoom, and we're going to use Slack for our real-time communication. I guess I've already sent, since I had to reach out to everybody in email anyway, I've already sent you an invitation. And please note that this is a Slack workspace, which is different from the one that the computer science department uses. I want to have multiple channels for this course, and honestly, I didn't even know the computer science department had one when I started using my own. And so I apologize for the multiple workspaces, but I need more than one channel to be able to communicate with so many people on so many different topics. If you want to get in touch with me, there's a couple of email addresses that I'll go to my inbox. There's whitlock@cs.pdx.edu. This is the email I've had forever. It's just, was what I use for PSU. Note that I'm not the only David Whitlock. We're going to have to go all Highlander and stuff, because I don't know how there gets to be two of us. This dude works over on the east side in some extension office in some art department or something. I don't know. It's probably looks just like me, but he's got a goatee and an eye patch, and that's the good Dave. But anyway, he is Whitlock at pdx.edu. And a couple years ago, I found out there were all these students that were sending him emails, which he probably didn't appreciate or have any context for. So that's why, like here in Zoom and on PSU, I'm David Whitlock comp sci. This is the computer science David Whitlock, not dude off in the art gallery or whatever he was. So my official PSU email, which makes no sense, is Whitlock CD. So instead of the K, it's with a D, at pdx.edu. So if you share a Google Doc with me or whatever, this is what you'll do. The web page, as we were pointing out, is that. And something very important. So years and years ago, I wrote a program to handle all of the grading, recording all the scores, computing the final grades, all that good stuff. And it is, and the first part of that is running this survey program. So log on to the PSU Linux machines and please run the survey program with this command line. It will ask you for things like your name and what your major is and all that kind of stuff. And what it does is it creates a little XML file with information about yourself, then emails it off to a greater email account. And then I have some machinery for automatically extracting that and populating my grade book. A big key to our shared success in this course is the ability to keep me and the graders available for answering your questions and for giving you feedback on your work. And so as a result, one of the reasons I've been able to scale this course to as many as 70 students is that I automate some toil work and drudgery like entering in grades and stuff like that. So please, this is really important. And I can't record any of your grades until you fill this out. So please run this program, the survey program, as soon as possible. Okay. Oh, another question from Andrew. I'll unmute you and lower your hand. Yes.
Yeah, sorry. Could you copy and paste that command line?
Absolutely.
Thank
yes.
you so much.
Yep. Good call. Wow. Okay. This Zoom thing's not so bad after all. Look at all this stuff I can do. Oh, and there are probably a couple other things on chat. Uproarious laughter emoji. Thanks, Sarah. Okay, so and by the way, can you see me typing into the Zoom chat right now? Probably not, right? Nope. Okay, good. Okay. Great. So on the PSU Linux machines, please run. I'll put $1. Oh yeah, good call on Slack also. Yeah, I'll just post that to Slack real quick. Done. And then I'll just put it over here in general. Please log on to the PSU Linux machines. Oh, and run this command. Nice. Okay. Brooks, thank you for raising your hand. I'll mute you. What you got?
Hey, so where it says your email at the top, it says you can get in touch with you at Whitlock with a K, but then
Yes.
That's the other Whitlock down below, and that yours is the one with the D.
Mine's the one with cs.pdx.edu.
Oh, okay.
Back a million years ago, well, a million years ago, like up until about 10 years ago, the computer science department had its own domain, had its own email server. This is back before the university had email for everybody. And so then, I got this email, not even knowing that there was an @pdx.edu. And so someone else beat me to it, getting the @pdx.edu.
Okay,
yeah.
I understand. Thanks.
Yep. Cool. Okay, any questions about the syllabus, about the content of the course? No.
Can I ask a question about the survey?
Actually, Kristen raised her hand first, so I want to give the floor to her, but then, yeah, turn it over here. So Kristen?
Okay, yeah, I was just wondering how, what the format of the quizzes and final exam will be. Was it like multiple choice, or will we do coding, or what kind of?
There won't be any coding.
Okay.
Well, actually, that's not exactly true. There won't be writing big pieces of code. I can ask questions about APIs, and as a matter of fact, on the first quiz, there is a question about coding, but it's in whatever language that you want. Now, most of the time, it's short answer questions about the material that's covered in lecture.
Okay, thanks.
Yep. So let's see here. Kaushik?
Yeah, I wanted to ask, you normally take this class in summer, and why I'm asking is because summer term is very short compared to others by at least some weeks. So is there anything you are reducing syllabus or course-wise, or it's
Yep.
same?
Good question. So actually, they've had me teaching this course in the summer for a number of years now. Clearly all the other professors want to go on vacation or something, and it's yeah, let's get the adjunct in here. So I hadn't taught the 11-week version of this course for many years until this past winter. And so really I had to add some stuff back in. So in the 11-week version of the course, and I don't know if they're going to offer that again, we have one more project. It's about XML. and we have another week of, we have 3 opportunities for pair programming and another 3 for mob programming. So really, we're not missing that much. And maybe did I throw in some other stuff too? I can't remember. So yeah, when I do the 11 week, it's a little bit more. It's a little bit more than it is here, but it's nothing super big or different. Thank you for the kind words, Dennis. David, Poole, question.
Yeah, so the survey asks for a Unix login ID. Is that the full DP? Like, would it be like the address at PDX, or is that just our name?
Just your username. And really, it can be anything. It's just something that I want you to use it consistently, because like for me, it's just Whitlock. And so, I mean, for those of you, it's probably some variation of your name or something like that.
Gotcha. Okay, thank you.
Yep. Scott asks, are the quizzes timed? There is a time limit. I've found, but because I don't know. I think but it's but students have not complained that it's not enough time, and anybody with DRC exceptions, let me know, and I want to make sure that you are accommodated appropriately. So let's see here. Box one, sorry, Bojwan. Yes, that is correct. If your email address is abc, or if you log into abc@linux.cs.pdx.edu, abc is the Unix ID. Yep. See here, Eve.
Ives.
Ives, thank you.
Yeah, so I had a question regarding the office hours. So is that going to be in this very same Zoom, or is there going to be a separate Zoom? I'm not sure.
I think, I don't know how to deal with that. And actually, that's a good segue into what I want to talk about next. So I haven't decided yet. And actually, I kind of want everybody's input on that. So let's, if you don't mind, just putting that off to the side for another couple of minutes, because I want to figure that out. Any other sort of general questions about the course or the syllabus or what we're going to cover? Okay. Well, so let's see here. So, gosh, I've been talking for almost 45 minutes now. And I'm trying to figure out how to pace the course or pace the classes. See, when everybody's in the classroom and I'm up there lecturing, I start hearing people snoring or maybe nodding off, or, it's clear that they're, on TikTok or whatever it is the kids use these days. And so I sort of know when it's time to take a break. It's kind of harder here. Do they actually have a little like snoozing icon? I guess they have the little coffee time for a break thing. Feel free to put that up if people need. And also, feel free, remember this is all being recorded. So if you need to step away and take care of a kid, or, use the bathroom or get another beer out of the fridge, hey, whatever it is, feel free to do that. I'm not gonna be, I can't see you. Whatever. But what I'd like to do now is get some feedback from you about how remote learning's been going. So I didn't teach last time. I taught in the winter, actually, for those of you who are enrolled in the winter term, we sort of in February we were seeing COVID coming, and then by whatever it is, the last full week of classes and the final exam. My final exam was remote. I was telling people, don't come into school if you don't come into campus if you don't feel comfortable for the second to last week. But I've never really taught 100% remotely. But I know many of you did take classes in the spring. And what I'd like to do now is go through an exercise that lets you tell me what you've learned about what's effective and what's not effective. And so then let me just take a minute here, and so many things on my screen. And I guess what I want to do is, I'll just create it here. Oops, wait for this tab to reload. So what I'd like to have, what to do is do a little exercise where we talk with each other about what's worked well for remote learning. Oops, there we go. I'll create Google Doc right here. Stuff. So there are a couple of questions that I'd like you to consider, and we'll do this as sort of a pacing exercise. So the first one, and I'll make this stuff this big, I guess, is what. Oh, could you please mute yourself, David? I'm going to mute you. Thank you. So this is all going to be about your experiences with remote learning. And so there are a couple of topics that I'd like your feedback and input on. So the first one, what has been effective in your remote learning classes? I'd also like to know what's been ineffective. What has been ineffective in your remote learning classes? And then what ideas do you have for making our class effective? So what I'd like to do is the following. I'd like to first take 5 minutes for each of you to ponder these questions yourself on your own, and then I'd like to experiment with using breakout rooms. Really, this is an exercise in making sure I know how to use breakout rooms. To then talk with each other. Let's see here. I'll do like maybe 10 breakout. No, that's too big. That's a lot of people. I don't know how many breakout rooms I'll do. I'll figure that out while you're working on your own. And then what I'd like you to do is talk amongst each other. I encourage you to enable your video cameras if you're comfortable doing so in the breakout room so that people can see you. And then I'll take, I don't know, 5 or maybe 10 minutes. I'll bop into a couple of the breakout rooms, see how people are doing, to talk amongst yourselves, to figure out, in the small group, what's been effective, what's been ineffective, and any ideas you have. And then before the breakout rooms, before I bring everybody back into the main room, please identify one person who will then do a report out from your subgroup on what your experience has been. Any questions about what we're going to do for the next 15 or so minutes? Okay, so please take, oh, yep, sorry, yep, Andrew, let's see here, I'll mute you, yep. Sorry,
I got it.
Thank you.
So are you asking about the situation from the teacher's perspective or from the student's perspective?
I want to hear from your perspective, students, like what have you seen that's been effective for you? Which maybe is things that the teacher is doing, right? But it's also, things that, either for your own learning, especially for, sort of the in-class time, but even maybe things outside of class in terms of, how you approach, maybe your homework assignments differently or something like that. I'm just curious to hear about your experiences.
So we're writing advice for both students and teachers.
Yes, anything that you want me especially to know.
Okay.
Thanks. Okay. I'll put a couple minutes on the clock here. I'll pause the recording because I don't think we need to get this part of it, and go off and think about this. Let's see here. Resume recording. Okay, and we're back. Wow. So hope that went okay. I popped into a couple of rooms. People were talking. This is good. Thanks for helping me understand the technology a little better. I'll go back to sharing my screen. Let's see here. Get all of the information up. I want to get the chat up in case anybody's chat. Good deal. I'm just going to go to active speaker view. Okay. Okay. It's an evil petting zoo. Huh. It might be. Awesome. Okay. So here's what I'd like to do now. Everybody who was selected to be or was asked to be to report out, would you please raise your hand? And then I'd just like to go through all those people and have them report out on what they found. And Slack gives me a million, or not Slack, Zoom gives me a million pop-ups. Let's start with George. Gonna unmute you, George Kingston. So what did your group talk about, and what were some of the things that they found to be effective, ineffective, and any ideas that they have?
Yeah, we spoke a lot about, for the effective aspect, we really enjoyed having lectures recorded so we could go back and reference it many times over. We also have had some professors that have pre-recorded lectures. So before class, which kind of would help us build on the information that we were either going to learn or had learned. So we enjoyed that. Not effective, we didn't enjoy the lack of uniformity in communication. There's a lot of ways to reach out to people, and so it kind of felt a little scattered, and not everyone enjoys that. And,
can you speak some more to that? Is that uniformity in tools, in style, in time of day?
I think, at least for me, and I know other group members mentioned different things, but it's nice when you're like in a classroom setting, you can ask questions before and after. It's just more difficult to like reach out. It has to be specifically during office hours, or if you send a Slack message, we can get an answer a couple days later. And sometimes there's different platforms that each class uses, so it's just felt a little scattered and wasn't the most enjoyable aspect.
Sounds good.
And then what can be made more effective? We really thought that good communication with classmates and professor was what could really make the difference.
Excellent. Thank you. I appreciate that. David Poole, you're up next. I might have
cool. Can you hear me?
Yep, sound good. Thanks. Go ahead.
Sorry, I unmuted myself on accident. All right, so I'm gonna start with what was ineffective, and honestly, it's kind of awkward to say, but breakout rooms. I've never been in a class where that worked very well. And for example, I don't think half of the people in my breakout room said anything. But I think that's a larger thing about what was effective is that in classes that assumed asynchronous learning, we're so much better, because if you think about what people are doing and that they're in their same bedroom all day long, some of us in dorms, that psychologically we can't focus very well. So I think assuming that everything is asynchronous and that doing your lectures and doing the learning and doing the communication in a way that is asynchronous made everything so much smoother throughout this entire thing.
Excellent.
And I think when it comes to ideas for making our class effective, I don't really have a solution for it. But for the people that I did talk to in the breakout room, and I do deeply agree that the thing that's missing with remote learning is communication with groups, and that like finding study groups and having that kind of communication with people around you and your peers. And I don't know if like breakout rooms or just assigning us to groups or that kind of thing is really the right solution. But there should be some way for us to find groups and work together in these weird times.
Yeah, okay, good.
I'm sorry if that was too much.
Not at all. That was great. Thank you very much. I really appreciate that. Sarah Haskew, you're up next.
Yes, hi. So I'll try not to repeat what other people have said, though we did mention that we really like having the online recordings, but you've already said that you're going to have that. And something that I found helpful in my other classes last term is, well, something like this, professors being open to feedback. Oh. Can everyone hear me?
Yep, sound great. Thank you.
Okay, cool. Is professors being open to feedback, and not only that, proactively asking for feedback and asking if something is working and making changes in real time when something isn't working. A tip for students is, well, we all enjoy like that there's no commute time. So sorry, what's working for students is like making sure we're following along in real time and following along in our own browser and own code with lecture. And I think the structure of actually going to class when class happens, when you can, versus being like, oh, I'll just go later because it's recorded, because I found when I tried to do that, I would get behind. So I'm just going to classes even though they're recorded. What has been ineffective is if there's too many D2L quizzes that are optional or easy to forget, but it sounds like we already have a structure for that in this class. And not realistic, but we don't like D2L. That's been ineffective, just in general. Ideas we have for making the class effective, maybe if there was a deliverables due date sheet so we could have in advance, like knowing how to manage and break up our time. And then one last thing that someone suggested is on the option of how to communicate with students, if we had a Slack channel that was dedicated for study groups, then we can see when people are available for studying to like organize that by like date and time people are available. Oh, well, sorry, one more thing. I actually do enjoy the breakout rooms when there is a clear agenda and maybe sharing tips. Like sometimes someone just has to kind of take like the first little charge and be like, hey, I started a Google Doc, I'm sharing my screen. Cause yeah, especially at first when we had breakout groups, it would take a long time for someone to like kind of talk, or we were all kind of doing it separately, and yeah. So sometimes maybe breakout rooms, but with more guidance can make them more effective.
Nice. Thank you. Okay. Excellent. Thank you very much. Let's see here. Also, the hand raise, Andrew Stevenson. Please unmute yourself.
Yeah. So what was effective? We found we love the pre-recorded lectures as well. Frequent breaks are an option, a possibility during the lecture, and that's something that's harder to do in the physical format because you have to get everyone out of the room and back down. And everyone's eagerness to use Slack. That's more so than what you would see in a standard classroom format. And also, I personally want to second what Sarah just said about the breakout rooms. It's the key is someone has to be willing to step up and start facilitating. As long as every breakout room has that is great. If it doesn't, then it's more difficult. Ineffective. Well, I had an experience with a professor who liked to ask a lot of rhetorical questions and then just wait for the answer. So in general, rhetorical questions are not great for this format. Also, similar thing, long diversions in class that the professor maybe can't tell from the student's body language that it's gone off track. And similar to the students, they can't talk to each other, maybe and show each other with facial expression that they need to see the floor. We had an experience with a professor giving quizzes that are timed during the lecture periods. That didn't go well for a lot of reasons.
Won't be the case. The final exam will be like that, but the quizzes aren't. Okay. Any ideas that your group had in terms of how we could work
Yes,
more
sir.
effectively together? Yeah.
We had a suggestion for a helps channel in Slack. And we had one to maintain the pacing lectures with frequent breaks.
Yes. Okay, good.
That's it for us.
Thank you. Excellent. See here, and Chastity? Did I get that right? Hi.
Yes. Okay, so we talked about the effectiveness, and we thought that we spend a lot less time wasted traveling to campus and like to different classes. So it's nice just having classes online, and you can pop out of one class and pop into another. We also really liked the chat window because if someone's presenting, other people can type in questions in the chat window and kind of follow a cue to answer the questions. So that's nice. And what we found ineffective, we had, well, a lot of us didn't like working in groups, forming groups and working in groups for like final projects and stuff. Because a lot of the time, you get into a class and you don't know half of the people in the class and you don't know whether other people have the same ideas as you for the final project. So it's kind of hard to get together.
Yeah.
Yeah. Also, some ideas to improve the effectiveness. We do like the breakout room idea, and I kind of wish that the professors would use that a little bit more because it has us get to know each other and kind of talk along the lines of certain projects and what we're interested in. And so it keeps us more engaged.
Cool. Excellent. Thank you very much.
Mm-hmm.
Let's see here. Mark Wignall, you're up next.
All right, try. It's getting harder and harder to get rid of duplicates. So,
And that's fine. And we're sort of at that point. We're getting a great long list. So if you're like, oh,
Yep.
nothing else to add, that's fine too.
go ahead and bump both the having lectures recorded and the following one, the pre-recorded. Both of those were valuable. Let's see. The office hours, as far as being effective, were highly effective, including the TAs. It was way better than in real life. I think somebody mentioned about not having to actually travel in and or get. It just seems like they were more available as a resource for us, either in scheduled times or even after the fact. Just coordinating a time with them worked out really well. In the actual office hours, having small groups versus just being private one-on-one with the TA or the teacher, or for similar questions, as long as everybody agreed that, hey, everybody's asked the same question, you all mind talking together, that was effective. And let's see, also the breakout rooms were very valuable. It gives us, it gives the perception at least of interacting with other folks, which we're simulating, so to speak, not having those actual in-person ones. Ineffective. The feedback from the assignments and projects, the score was just simply not enough. DTL was a common theme for the vehicle used for doing the grades, but just getting a score and let you know which problems were wrong wasn't effective enough. Having what was wrong and having discussion about it usually required a TA or getting to office hours scheduled so you can actually go over the submission. That didn't work too well. Let's see. Lectures that were conducted from the whiteboard. It was very hard for the instructor to see questions being typed or raise their hand, etc. Just lost the awareness, so that's not good. Doesn't sound like it's a problem here. Long lectures without any scheduled breaks was ineffective. Sounds like we've got that nailed as well, so not too much of an issue.
I don't know. We still got a ways to go tonight. ask that question again in another 2.5 hours when we're still here.
Well, I thought I heard you mention earlier that there will be some. So anyway,
yes.
And then also really did not enjoy reading from slides, like not just literally reciting what they're. We can do that on our own. So
you can watch that on YouTube in my course.
Yep, yeah. Ideas, code examples that were to be reviewed with the class that were actually from an actual student submission with being anonymous. This gives us the, hey, how are our peers doing it, not just from the top down or a quote pro doing it. Just give us give us some kind of how we, relatable. Let's see, an actual rubric for graded projects, how and what goes into a good score. Not having that was very hard to know what was being required, especially after the first assignment when you're waiting for that to come back. And then other ideas, I think you mentioned it, but live coding sessions would be really, really good. Not just having the final code examples being available to us. And specifically on that, seeing the progression that was made over it, not just like hey, go here's this link to see the final version. It's nice to see the build up.
Yeah. Excellent.
That's all we had.
Thank you very much, Mark. That was great. Okay. So we still got like 6 people with their hands up. If you're looking at your list and it's like, all my stuff's already been covered, feel free to lower your hand. It won't count against you or anything like that. But let's see here. Dan Ferd, how about we go with you next?
I really only have one thing that hasn't already been covered. And what's been ineffective is exams. Essentially, we don't understand how the questions will be worded or really what we're getting into. And we can't really ask questions directly in most cases immediately to get feedback. And that has been an issue.
Yeah. Yeah, I can definitely see that. I think during the final exam last time, I had asked people to privately chat me, and then it was okay. That question is for everybody. I would just say it. But yes, yep, that's definitely a challenge. Luckily, though, our exam isn't worth very much, so even if you miss a question or two, it's not going to kill your grade. Okay, thanks. Let's see here, Alex, what would you like to contribute?
Yeah, so things I haven't mentioned, people in our group brought up that sometimes having like a whiteboard program or something you can draw and erase can be useful for things that work. And things that don't work is that sometimes with Slack and group projects that people are not checking in, so you're not getting they're not getting your messages or questions or comments or whatever. So maybe students setting up regular meet times could be helpful for that.
There will not be those kind of group projects in this course. I've resisted the urge to do that. Oh God, I remember what it was like when I was a student. I mean, there were some classes where I had a group that was just so awesome. We got a lot, and other times it's like I'm doing all the work. It's like, nah, I don't want that to be this class. However, what we do instead is we do pair programming and mob programming. So you do get to work with other people, but it's lower stakes. It's a much shorter engagement, and so then I suppose if you get someone who's really awesome, it doesn't last long. But also if you get someone that you're not compatible with, it doesn't. You're not facing the consequences of that for the entire course. Good.
And then the only other thing, sorry, there's one last thing, is that a suggestion for the things that could work in the class is having students share their code when they have issues on assignments and maybe working through that.
It's something that we haven't done in the past. It's kind of easy to do that, but I think in practical terms, when people have encounter problems, we can work things out over Slack as a group without here's all my codes. We're like, oh, I'm getting this exception. Why? But we definitely have worked with a lot of people during office hours and just, the two of us looking at the same piece of code. But excellent. Okay, cool. Thanks. Scott.
Yes, sir.
What you got?
Okay, so as far as what's been effective, a couple things to add here. Pre-recorded lectures, we really do like the pre-recorded lectures, and some people have made mention of that prior to this. One thing that we kind of have to add is that it's nice when the cumulative time between pre-recorded lectures and class time kind of totals somewhere in the general ballpark of what's allotted. What we have gotten into, or at least I've gotten into, is where we've got, a 3-credit course with 8 hours a week of lecture, and that can get kind of cumbersome between the pre-recorded and the in-class stuff. Another thing is that works really well is when the instructor sets time expectations for in-class and out-of-class, well, primarily out-of-class materials, how much time they expect us to be spending on something before we're just kind of spinning our wheels at that point. Things that have been ineffective in our experience, we mentioned, some people have mentioned breakout rooms being effective, some have mentioned them being ineffective. I think that one thing that would make them effective is if there is a facilitator who either volunteers at the beginning of each session or is assigned by the instructor. They can kind of flounder when we don't have that available.
Yeah.
And some other people have kind of touched on that. Last thing we would mention with regard to making class effective, and you seem to have done this at the beginning of your lecture here, is setting a policy on how to communicate in class, i.e. speak freely or raise hands or chat in the window. Otherwise, I know that the instructor can kind of be shooting their eyes all over the map, and I think students, end up doing the same.
Great. Thank you. And finally, Max, I think you'll have the last word on this.
Hey, yeah. So I know a couple people have mentioned that pre-recorded lectures were effective for them. I actually had a really bad experience with pre-recorded lectures last term. I had a class with a professor who I had taken the term before in person, and it was like night and day. I mean, it's just the problem with pre-recorded lectures is that if there are mistakes, they don't get addressed, and that can really make things frustrating when you go to start working on something and you realize that you have contradictory information. But to that effect, the things that I do think were effective were the chat function in Zoom. I think that's the best part of online education, in my opinion, because you can have not only people asking questions with less pressure in class, you can also have people answering and communicating without interrupting. And also the office hours. I'd never been to office hours before online office hours were available, because I just didn't have the time to set aside an hour to go out of my way to somewhere across campus. But now that it's just clicking a link, it's been extremely helpful.
Sweet, awesome. Oh, and Alexander, I saw that you also raised your hand.
Oh yeah, I just had one more thing to add about the pre-recorded lectures. I had a class last term where they were uploaded to D2L, I think, and the interface that they use for videos is pretty difficult to navigate. So I was hoping maybe there's a way to like upload them to a different platform or allow for downloads as well.
So yes, all my lectures are up on YouTube. I don't have an easy way to download them, so I hear there are ways of downloading things from YouTube.
No, YouTube is great. It's just like the D2L interface is kind of funky. So.
No, imagine that.
Yeah.
Yeah. Okay, cool, excellent. Well, thank you very much for sharing all of this. Sorry, the interface is wonky. I was, really these last 12 weeks between terms, I was curious about what other professors were doing, sort of how you manage all of this. I mean, I think probably like many people, you've been thinking about the how different we've all had to do our jobs, and whether our job is being a student or lecturing, or gosh, I can't imagine being like a second grade teacher and trying to do all that remotely. These are great ideas. I'm going to go read over this list. I think there's some good ideas that I can implement easily, especially around things about Slack. And I really appreciate all of this feedback. As a matter of fact, one of the things I'll put into practice right now is taking a break. Let's take, not too long of a break, let's take 10 minutes. So get up, please stretch your legs, do what you need to do, and we'll return back here at 6 minutes past the hour. Not sure if I like that robot voice or not. Okay, welcome back everybody. Okay, so at the beginning of class, we did a lot of administrivia, right? We learned about who I am, who the graders are, talked a lot about the nature of the course, went over the syllabus. Thank you again for doing that activity to inform me about what works well and what doesn't work well when it comes to remote learning. Now let's write some code, right? That's what we're here for. So one of the challenges with any course, and this course is no different, is how you get started, is how you learn about sort of the fundamental tools, how you configure your environment, so that you can start programming quickly. I've evolved quite a bit over the years, and what I'm using now is a special GitHub repository that contains sort of the stuff that you need to get started. This has worked. I've been using it for a couple of terms now, and I think it's been very effective at getting everybody off to a quick start and everybody at the same level. So even if you've never really done much with Java before, or you don't have a lot of experience, working with, a development environment, it gets everybody off on the same step. So I've got a getting started GitHub repository in GitHub. Oh, which by the way, I hope you're all familiar with Git and GitHub, or at least enough to sort of navigate. This isn't a course in Git, and technically this isn't all required, but this is, trust me, the way that you want to go. Even if you never check into your code into GitHub, and I recommend that you do check in your code to GitHub and use it to manage the use version control for your code. It gives us a central location that we can all go to and work. So I'm going to post this URL in the chat real quick for everybody to see. Oops. make everybody send chat to everyone in meeting. Okay, cool. So if, I encourage you to play along at home as I go through this here. So one of the so you'll be working with a number of Java projects. These are programs that are written in the in Java programming language, and you'll be learning about test-driven development, and you'll be implementing your projects, all this kind of stuff here. And the way you get started is by working with this repository. One of the nice things this repository does is it lets you get up and running really easily with what's called the Apache Maven wrapper. Now, Maven is the tool that builds all the projects. There's some lectures on it. You'll see lots of examples of here shortly. But as actually a couple of you noticed, and there was some conversation on Slack earlier this week, is that, okay, downloading, installing, configuring Maven can be kind of a pain, and depending on what your machine is and how locked down it is and stuff, can be kind of awkward. I've tried to remove all that awkwardness by using what's called the Maven wrapper, which is a shell script that will go and download Maven for you and take care of all of the heavy lifting. And I have links here that you can go and follow to learn more about all of this. So in order to use this repository, you need the Git tool. Git is used for version control, and GitHub is this website, the central repository for central location for a bunch of GitHub repositories. And so I've been using Git for a number of years, and I highly recommend it for this class and for using it to manage your code. If for no other reason, it makes it pretty straightforward to move your code from one machine to another. And this will be important. I'm guessing the vast majority of you will develop your code in your local development environment, on your laptop or on your home machine or whatever. And as a matter of fact, I don't have an option for Android for anybody who doesn't have a machine. So if you don't have a machine, or if your machine is really, really old and might not be able to run Android, please reach out to me now, and we'll try to figure out how we can best accommodate that. But anyway, by using Git and GitHub, you can basically make changes to your source code and save everything to the cloud. That sounds like a marketing thing, but it's true. It's you push everything up there, and then you can easily pull it down onto the Linux machine that I'll be using to test it. Because that's where you'll submit it, and I want you to test it out first. So anyway, we'll see examples to how to do all of that. If not tonight, then very shortly in class, maybe next week or the week after that. So if you haven't already done so, or if your machine doesn't come with Git installed already, please install that. Now, those of you who are familiar with Git, you know that one of the first things you do when you have a repository that you want to you clone the repository into a local checkout of that repository from GitHub. We're not going to do that here exactly, and here's why. This repository is in my organization, and you could clone it, and you can make some changes, but you're going to do things like implement your assignments. You don't want to then you can't push that back up to my repository. Instead, you're going to want to have your own repository in your own organization, and you're also going to want to make it private where mine is public, right? You don't want your source code out there for everybody to see. It's more likely someone's going to plagiarize it that way. So more about GitHub, et cetera, et cetera. So what we're going to do now is I'm going to walk you through some steps. Feel free to follow along at home. And if you just want, if you just want to pay attention now, you can follow the steps later, maybe watch the recording at the same time. And what we're going to do is we're going to create a new repository for all of the source code that I'll be developing, and you'll do the same, the source code that you'll develop for this course this term. So you can create, go get an account, do all of that, and then create a private repository for your source code. So actually, let me, let's go over here, actually. Got another GitHub tab open here. I will say create new repository. Okay, and so the name of the repository is going to be Portland State Java Summer 2020. Here. It's available. That's good to know. I'm not going to put in a description right now. As a matter of fact, neither should you. You are going to make your repository private so that only you can see your source code. I'm going to make it public so everybody can see my source code. And do not initialize it with a README, and we'll see why in just a moment. So I'm going to create that repository. And don't put a git ignore and don't put in a license. Trust me on this one. So I'm going to create a repository. Great. Now I've got my new repository up there in GitHub. Now, there's some Git magic here, because what you're going to do is you're going to take my repository and use that as a starting point for your repository, right? So we've created the repository. Right now it's got nothing in it. No source code, no revisions of anything. And what you're going to do is going to take my repository and put it into yours. And that way you'll get all my code. You'll also get all my Git history, which is kind of a little weird, but whatever. You'll get all of my code and it'll all be in version control. Oops, I hear Slack speaking to me. I hope that's not people trying to ask questions, because I'm not. Can you share a screen? I can see his screen. Yeah, I'm sharing my screen. So George, I don't know. Hopefully everything's okay. Perhaps you just don't have a Zoom in the foreground. That happens to me all the time. Okay, so we're going to do a little bit of Git magic here. You're going to do we're going to make what's called a bare clone of your repository. And basically what this does is it checks out all the files and all the Git history, but doesn't really tie it back to where it checked it out to. I'm going to do this on the command line here. I'm going to do that from my Git directory. You can put it wherever it is that you want on your local device. So I'm going to make a bare clone of my Getting Started repository. I'm dealing with two repositories here. There's my Getting Started repository, which is what you're all going to copy. And then I'm also going to use my Summer 2020 repository, which is which each of you will have in your own organization. And if any of you have questions during any of this, please feel free to raise your hand in Zoom. I'll try my best to pay attention. I've got the window right over there. Okay, I've now created a Git repository. It's created this Portland State Java. It's created this .git. I think it's a directory. Yeah, it's a directory. That's neat. So I've got that. Now I want to do this magic where I CD into that directory. So I go into that directory. I wonder what's even in there. I think it's actually the .git directory or something. It's got all of the database and everything like that in Git.
Sorry, what did you run? Git clone -- bear, and that's
yeah, click clone bear. Yep. Yeah, that comes from mine. And then what you'll do is after you get that, you should have a directory called Portland State Java Getting Started.git, and then CD into that directory, and then we will push to the new repository that you created. And so here you change your GitHub user, which is for which for me is David Whitlock, and push it there. So what this is going to do is it's going to say, hey, all the changes that came from my Getting Started repository, now I'm going to push it into the Summer 2020 repository. Oh, okay. Sorry. You can use HTTPS. I am going to use the Git URL because I have keys set up. Oops. Okay, so now that I've done that, now I go back to GitHub, and if I look at my Summer 2020 repository, if I just refresh this page, now all of a sudden it's got a whole bunch of stuff in it, and what it's got in it is the same stuff that was in the Getting Started repository. So if you go back up to the top here, as you can see, it's got the same commit. It's got 7A4, 7A4. So basically what I've done is I've made this disconnected copy of my repository. Now, for those of you who are following at home, let's see here. Can you use? How about give a thumbs up, give a like if so far this is making sense to you. Yep, or use that. Yes. Oh, good. I got okay. Got a couple people who are no. Oh, that's really neat. I've never seen that before. So let's see if I click on this. Oh no, that's the my vote. Oh, interesting. But I can't. Okay, so it looks like yep, almost everybody's got it. Anybody have any questions? Feel free to raise your hand if you have a question. I did notice that there was someone asked to go slower. Someone else said no. Okay, but just to review, and you're right, I was going really fast. I tend to do that. So the idea here is that I've got this repository for getting started. And the best way for you to get that repository to get started is to make this fancy clone of it. And so you do the clone-bear, and then you push it into your own repository. Okay, I'm going to move on since there weren't any questions. So now, off in my summer 2020 repository, I have, yep, all the revisions, all the information that I need, and this is good. So I hope so now you have all of this. So now you can start doing your stuff in your repository, and then you can use GitHub just like you would normally. But you've got like all my stuff already in it. So now that I've created the repository, I want to get a local checkout out of it. I want to make a local clone. And so I'm going to, first of all, get rid of this Git directory. I don't need it for anything. Getting started.git. I'm going to get rid of that. And now I'm going to make a clone of my summer 2020. My summer 2020 repository. And now, pointers in Java, summer 2020. I've got all the files here on my local machine that are in GitHub. So that's good. Okay, and so again, what I've done here is now I have my own playground, my own repository for all of the code that I'm going to write for summer 2020. And you can do the same. This is where your project code is going to be, is where the cones are going to be, all sorts of good stuff like that. Kind of advanced Git stuff, but it works, and it's a good way to get you set up with a repository. Now, there are a question from Seth. Yes, Seth?
Hey, I was just curious, when you said not to choose the git ignore and the readme, is that just because you have those in this repository, or
yes.
Okay, should we use those defaults regularly for a Git repository?
No. So if you're creating a new repository, you're starting a project from scratch, yeah, you definitely want to git ignore. You should have a license. Your code is important. You want to tell the world how you can use it. So yeah, so if you were starting, let's say you're working on a capstone or you're working on another class where you have, we're going to collaborate in GitHub, or you're starting your own personal project, definitely use them there. But in this case, because what we're doing, we want this empty repository that we then import a whole bunch of version history into. You want to start with a clean slate. Otherwise, I think the push will get conflicts or something, and that's just not what you want.
And so we want to delete everything or that .git file that you have given us, and then clone our personal repo again, so we have everything locally.
Yes, exactly, right. So the .git file, .git directory, you don't need it anymore. And there's nothing you can do with it really. You can't, it's not a checkout, it's not a clone, it's like the raw files or the bare files, yeah. Good questions. Okay. There are a couple of other things that you need to do before you can really start using the repository. So the first thing you need to do is install the latest version of the Java Development Kit, and I recommend. Let's see here. Okay. Oh yeah, this is the. Is this OpenJDK? Yeah, this is. I think. Yep. And so you can download it here. It might also come with your with your operating system. or you can use your package manager or whatever makes sense for you. So that's how you can install Java. And so there's and you want the Java development kit. You want all the tools, the compiler, Java doc, all the other things that we're going to learn about. So make sure that's there. I'm not going to walk you through that. There's also some configuration that you need. Oh, Cyrus, yes, you had a question?
Yeah, so does the JDK come with, if you're using the CS computers remotely, is it already on there?
Yeah, actually, and let's just talk about that real quick. So let me log on here. Now, the easiest way to configure your environment is to use the add package command. Hopefully you're familiar with this. This is something that the cat guys put together. You want Java 12. That's what they've got here right now. Java 14 is also available. I haven't asked them to put it on there yet. It doesn't really get you that much in this course. But yes, configure that there.
So you do have to add it, install it though. It's not already on there.
No, I'm sorry. It's installed, but you need to configure it for your environment. So what add package does is it configures your execution path. All right, so I've got all sorts of stuff on my path, and so here's the Java that I use. I use Java 12, and the way that you that you make sure is that you say Java version.
Okay, thanks.
Yep, that's on the CS department's machines. Okay, so get yourself a Java, get yourself a modern Java, so Java 12 or later. There's also a Maven configuration file that you need. It's called settings.xml. I give you a template one right here. Actually, this is probably all you need. Yeah. This is an XML file that Maven uses, and it basically tells you which Maven repository my code is deployed to. And so then this is something that you need to use exactly once here at the beginning of the course. So make sure to copy the settings.xml into the .m2 directory inside your folder. I like Andrew's comment. Yikes! Just hit me. This class is only half over. Yeah. Actually, wait. Isn't this supposed to go until 9:30? Oh yeah, I guess it is halfway ish. Yep. There's a lot more tonight in advanced programming with Java.
Can you repeat the copying the settings? What do we do now?
Yep. So let's see here. Well, if you're on a Unix machine, a Linux or a Mac, make a directory in your home directory called .m2. On Windows, it's what, the %home directory? What is it even called these days? Let's see here. Let me just open up a new tab here. Maven configuration. Where's configuring Maven? Yeah, so it's used to say, where's Windows? Oops. Oh, this doesn't. It's this .m2 file in your home directory. So wherever your home directory is on Windows these days. And create a directory called .m2 and then copy settings.xml to that directory. Okay, now for the moment of truth. Do you want standard edition for Java? Yes, you want standard edition for Java, not enterprise edition. Now it's time to create and run your first Java project. Now, I use something called Maven archetypes that sort of makes a project template that you can customize a little bit, and it creates all the files that that you need for the project, or at least to get started with the project. What we're going to walk through now here is create something called Project Zero, which is a student project. Let me just walk through these instructions and then we'll actually take a look at what the student project does. So the first thing you do is you run a script that's there in your checkout called create project zero. Well, I'm not going to look at the details of it. And then it takes one argument. It'll say that you're missing your student ID if you don't have it. And this is, I've always had people use their Linux login ID because I know it's going to be unique. And so this lets me know, whose code is being submitted. So I'm going to run that script with my name. This does a couple of things. It downloads the Maven wrapper, and it goes and creates a new project directory. And sure enough, oh, and it looks like some people are asking some questions. So let's see here. Yes, so yeah, there's a question about the Maven wrapper, and I'll get to that in just a second. And so, there's some question about environment variables, and no, you do need to set your Java home environment variable in order to use Maven, I'm pretty sure. And I'm sorry, I'm still running Java 11 on this machine, apparently. I'm going to fix that real quick. Oops. There we go. Okay. But yes, there was some question about, hey, do I need to download and install Maven? And I'm sorry for those of you who watched the Getting Started video, I talk about that. That is, oh boy, that video is like 3 years old now, and I only introduced this whole Getting Started thing a year ago, I think, and I now realize I never went back and updated that. So I'm sorry. I know that one of like the things that makes things ineffective are pre-recorded lectures with wrong material, so I failed that one right away. But maybe those lectures from like 2013 are still okay. Please let me know if you find more things that don't make sense or seem inconsistent. So you're running Java. We ran that create student, the create student script, and that created a directory called student. Now, so I don't have anything about Java on home in here, do I? I don't. Okay. So I will need to add that. It created a directory called student.
So you're saying you want us to create a directory called student in our repo here?
It's the create project 0 script is the thing that creates it.
Okay.
So when you're in create project 0, it creates a whole bunch of stuff. Do I have an ls-tree on this? No, I don't. It creates a whole bunch of stuff. We'll take a look at it in a minute. But most importantly, what it creates is this thing called the Maven W script, the Maven wrapper. You need to make this file executable. So on Linux, you do chmod +x for the Maven wrapper. And now when I run Maven wrapper, this will run Maven. It'll download all the stuff that you need and say Maven wrapper verify. What verify does is it takes your Maven project, through its entire life cycle. It'll compile all the source code, it'll run all the unit tests, it'll run what's called the integration test, it'll build any artifacts, and make sure that the entire project can run successfully. And as you can see here in the background, it's doing all sorts of things. It's running unit tests, it's building jar files, it's running integration tests, and phew, everything ran. Now, the first time that one of you run it, very likely, it will download what seems like the entire internet. So one of the great things about Maven is that it manages all of the dependencies that your projects have. So one of the things we'll see a lot in this course is that we're using other people's code a lot. And whether it's code that I've written to give you like an abstract superclass that you need to implement, or you're using a third-party framework like JUnit to write unit tests. And one of the challenges in developing software is managing all of this third-party code that you leverage. Well, Maven takes care of that by allowing you to say, hey, listen, I want this artifact, and things that you configure, like in that settings.xml, are where those artifacts get downloaded from. And Maven does all the heavy lifting of downloading those artifacts to your local machine, storing them off in a well-known location that it can go and find them again. So it doesn't need to download them every time. And so then when you run your projects for the first time, it'll download a lot of those things. I, of course, had stuff downloaded years and years ago, and no one wants to watch, a whole bunch of stuff being downloaded on my screen. So I'm going to pause again for feedbacks. And actually, if people were voting with the yes and the no buttons, and that seemed to work out pretty well, so forget the thumbs up and stuff. Yes or no, have people been able to follow along? Have you been able to create the project and run your first Maven build?
Sorry, can you say again the command to create that student directory?
Sure. Yep. And all the instructions are here in the in the README.
Oh yes, so
on that, right?
that command right
Yep.
there.
So just run this right here. Yes. Okay. There are a couple people who have said no, they haven't been able to do it. If you'd like to get, if you want to talk about it for a little bit, please raise your hand and we can help you work through it. Yep, Max, you're the first one.
Yeah, I think I just missed something along the way. So I got to create project 0, running that command, and I get found Java executable in execution path. You're running Java version 1.8. This is insufficient. So I don't know.
Too old. Yep.
Something. I just installed JDK 14 though, so I don't know what's going on there.
So what's most likely the case is that it's not on your path. So what operating system are you using?
Windows 10.
Okay. So and you're in a shell of some sort, like a git bash or a command or something?
Yeah, I'm using git bash.
Okay. So if you do a Java dash version, what do you see?
1.8.
Okay, well that would do it. So your environment isn't set up. Let's see here. You might need to create a new git bash shell. So if you close that one and open up a new one, run Java dash version again and see what's been updated.
Okay. Nope, still says 1.8.
Okay. Well, so then you might need to set like the Java home environment variable. And I don't remember. I thought Windows was better about that now. But maybe in git bash, you need to change your bash RC or something. So,
yeah, I might try a different terminal too.
Okay. Oh, it looks like Roland is, he said that he had the same problem, and to fix it, I had to move my JDK directory over my normal Java directory in the path variable. Yeah, you might need to adjust your path also. Okay. Yep, so maybe you could work with Roland to make sure all that gets worked out. Looks like someone had raised their hand, but now they've lowered it. Good deal. Okay. So now let's turn our attention to this student project. So let's see here. Where's project 0? Project 0. So the projects for this course kind of followed this same template. And boy, like the very first time I taught this course, I had this project 0, which was like, yep, just get started, a very simple program. So the whole idea is that, pardon me, that here in this project, this is just for demo purposes, just for getting started and playing around, is that you're going to write a very simple student class. And this subclass is one of my classes called Human, and we reference it in the lecture notes. You implement some stuff and it has a simple command line interface. And the goals here are the following. You want to be able to work with someone else's code. It's my code, and it lets you learn about overriding methods and working with inheritance, and also reading program arguments from the command line. And so there's the student class here, and this student class is actually created when you run when you run the create project 0 script. And actually, we should probably just take a look at that in IntelliJ. So let's look at some Java code. Now, this is the year 2020. When it comes to editing code, yeah, you can use VI or Emacs or any of those other any of those other tools from the 70s. But while you can be, very effective in some languages, some environments, in those, there are modern tools that help you go a lot faster and navigate large code bases much easier. It's the integrated development environment, right? The whole idea is that you have not only a code editor, but you have something where you can run your code, where you can test your code, where you can get analysis of your code, help all in one application, all in one interface, so you can go faster. And so then you're not constantly going back and forth between an editor and the command line to build things. Everything's all integrated. There are a number of editors for Java out there, and the IDE that I like the best is IntelliJ. I think it's, in my mind, it is sort of the industry leader. It has the nicest features. And they keep it up to date with Java, and it's intuitive, easy to use. I highly recommend it. They have there is academic licensing available. It's free. As a matter of fact, I think Portland State even has some deal. So all you do is put in your PSU address, and they'll send you a confirmation email. It's really easy to get a license for the course. So highly recommend this. So to get started with IntelliJ, what you're going to do is so you're going to create a IntelliJ project from your Maven pom.xml. The pom.xml, that, as you'll learn in the lecture, is the configuration file for your Maven project, and it configures all sorts of things about your project. The name, what all the dependencies are. Any special configuration for building it, et cetera, et cetera. So that is a file that represents the project that you're building. And if you open that file up in IntelliJ, so we go and let's see, it's from a PSU directory, and we'll use our summer 2020, and we'll open up student, and we'll actually, you know what? Let's open up the parent pom.xml instead. It says, hey, I recognize this file. It's a pom.xml. Do you want to open it just as a file or as a project? For an IntelliJ project is what we want to open it as. So we'll click Open as Project. And it's sitting there. It's resolving Maven dependencies. It's doing some analysis of the project, of all the files here. And sure enough, it's found this project, this parent project, which is Portland State Java Summer 2020. It has a subproject for student, and this is the code that we've created. And all of this is the same code that's here on the drive right here, right? It's got Portland State Java Summer 2020. It's got student, and then inside student, it's got the source directory, and inside source, it's got IT main and test. This is the source, the integration test, the main and the test directories are all the standard Maven directories, and that's what Maven expects. That's what's conventional. That's how Maven is able to do a lot of what it does. Seeing some questions go by, you've been asked, can I use other IDEs? I have used Eclipse for a long time. If you want to use a different IDE, you are welcome to do so, but I'm not going to support you. And so if you find yourself in some crazy situation with Eclipse or NetBeans or whatever else out there these days, I probably can't help you very well. But if you're really familiar with it and that's the environment that you like, yep, go for it. Eclipse has good integration with Git, and I think everything that you'll need to do in for most of the class, you can do in Eclipse. When we get to the end of the class and we start using Android Studio is built on the IntelliJ platform, and so if you're already familiar with IntelliJ, Android Studio will feel very natural. But yeah, definitely use Eclipse now. So back to the code. As we look, was that a question? Sorry.
Sorry. Shouldn't IntelliJ already have the development kit integrated in with it?
The JDK development kit, or you're talking Android?
Yeah, the JDK.
No, I mean it comes with its own Java runtime, but it wants you to tell it where where your Java installation resides.
And where do we set that environment variable for the JDK?
Well, it's not an environment variable. What platform are you on?
Windows.
Okay,
I
yep.
try to run your command to create the folder, and it wants me to set the Java home variable.
Sorry, are you talking IntelliJ or Maven?
IntelliJ.
IntelliJ. So, so IntelliJ wants you to set the Java home environment variable?
Yeah, when I try to use its own terminal to run your command to create the student directory, it wants me to set the Java home variable.
That's probably right. Okay, sorry. Set the environment variable inside the terminal. So you're like doing terminal down here?
Yeah.
Yep. Yeah, that doesn't surprise me. So I don't know what this uses for on Windows. I don't know where it goes to find Java home. Does your like your does your batch shell, but your batch shell, your CMD, your sorry, I'm lost for words. Your terminal, your command window. There you go. That's the word. Command window. Does it have Java home set?
I mean, it seems to not. I've never seen this before. I program in Java all the time on this computer.
Right. Okay. Well, so maybe then don't use the IntelliJ terminal.
Okay.
I'm
But
really
we
not too
can
sure.
set the environment through the terminal.
I think so. I haven't done that very much. I don't really know that much about the IntelliJ terminal.
Oh, you're just saying run the command through like PowerShell.
Yeah. Yes. Yeah. Sorry. PowerShell. Yes. Right. Yeah. It's the year 2020. They have things like that now. Sorry. My Windows knowledge kind of stopped at Windows 98. Yeah, Windows 95. Sorry. Good. Looks like people are getting work, but thank you for asking that question. Here in IntelliJ, we can open up the student file, and this is the file that's right here in source main Java edu pdx4j Whitlock student. So we got the file right here. So this is a Java class. This is a Java source code. This is some of the first source code we're going to see. And this talks about a human. And so a human, there's a constructor for it that creates the object. Oh, it extends human, and human is in the edu pdx cs410j lang package. You know what, I'm going to assume that most people remember these sort of Java 101 things from the 200 level course or whatever. So when I say package or extends it, you know what I mean. If I'm talking about Java stuff that maybe you don't remember or maybe never learned, please raise your hand and I'll reiterate some things. But the student has a number of properties. So it's a constructor. Every student has a name and takes some number of classes that are represented as an array list of strings, has a GPA, and a gender that can be male, female, or other, all case sensitive. And then it's got some instance methods. And so then there's a method called says, which overrides the says method from human. And right now it just well, what it's supposed to do is all students are supposed to say this class is too much work, but we're just starting out here, and so then you start out, it doesn't do anything, it throws an unsupported operation exception. Students also have a toString method that returns a string that describes a student. We'll take a moment a little bit later to see what that's all about. And it has a main method, right? And so main method is the command line, is where the command line program starts. Now, at the beginning of this course, we're going to be working from the command line, and we're going to be writing as command line applications. Because at the beginning of the course, we're going to focus on learning about the internals of a Java program and not so much about the user interface. Don't worry, we'll get to the rest project, and when we get to Android, definitely we'll be seeing different ways to interact with the programs. But for the beginning of the course, we're going to be focusing on the command line. So these are all the pieces parts of this student class. Okay. Now, a little while ago, we ran that Maven verify command, or actually it's the Maven W verify command, to build the project. Actually, we'll just do it again. And this is the thing that went through and compiled all the source code and ran all the tests and all of that good stuff. And one of the things that it did is it built a jar file. Now, a jar file is a Java archive. And basically what this is it's one file that contains all of the code and any static resources like image files or sound files or text files or whatever that's needed by a library or application. And this file is, this jar file is created in a way that makes it what's called an executable jar, meaning that when you say java-jar and then give it the name of the jar file, creator, student, what it does is it runs the main method. In this case, it's the main method of the student class, which just says missing command line arguments, which is exactly what this does, right? So this prints missing command line arguments to standard error and then calls system.exit with 1. And so we can execute it that way. Your assignments are going to follow a similar pattern at the beginning until we get to like the more interesting user interfaces. Let's take a moment and learn a little bit more about the student project. So when you run the student project with arguments, with command line arguments like Dave, mail, 3.64, algorithms, operating systems, and Java, what we want the student program to do is to print out the following to standard output. Say Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. So what this assignment and what you do is you take in these command line arguments and you leverage the student class to ultimately print out this text, and this is what's returned by the toString method. And so this is the kind of stuff that you do in student. Before we go back to the code, there's something that I wanted to address with this project. And I had used this project for many years. And a couple of terms ago, after I had gone through and I talked about how the student is modeled, one of my students pulled me aside. Their name is Prerna. And they said, there's something that we did in class that made me feel uncomfortable, and here's what it was. Prerna doesn't identify as male or female. And they said, as a computer programmer, there's something that I want you to know. The program that you're having us write, I can't test that on myself. I don't know what to put in there. That program doesn't apply to me. And as a software developer, as someone who writes code, the work that I do, I want people to use it, and I want to make sure that the things that I put out in the world are accessible, are familiar, are usable by people. And so then we engaged in a really great conversation after class, and I learned a lot from Prerna and what they were telling with me. So then so as a result, I modified the assignment to not have the binary gender. So I used to represent gender as a Boolean, true for male, false for female. Even that doesn't seem right. Like, how do you, what is the most effective way? What's the proper way to make sure that the data that you're representing the data that you're representing applies to all of its users. You can read over this, but it was a really important lesson to me. And this is a story that I tell now about this project because, not only does this seem more applicable from a social standpoint, but also from a software development standpoint. We want to make sure that the work that we're doing can be consumed and can be consumed by the maximum number of people so that we can do good in the world and so that people feel comfortable using our software. So an important note about gender and how we deal with it in this project. Back to the code. So right now I have this student class, and it's very bare bones, right? It's not doing very much right now. Now let's explore what it does. Now, also in this Maven project, off in the test directory, there's something called student test. Now, a student test, this is what's called a unit test. Now, there's a lecture about it, and I would ask that you all go watch it after class once, if you haven't already. And what a unit test does is it exercises a particular piece of functionality. Testing is very important. As a matter of fact, we'll talk a lot about what unit testing is next week and sort of how it applies to your projects and everything like that. But what I wanted to do is I wanted to show you the code and start working with things, walking through things tonight. So the first unit test that that is run is called student named Pat is named Pat. And so I want to validate that when I create a student whose name is Pat, that yes, when I then ask that student object, what is your name, it returns Pat. And so I represent that, or I encode that using the following. So it's just Java code. I have a method called this. It is annotated with this @test. So this is what's called an annotation. This is a symbol that you can put before method, field, and class names that indicate that there's something special about that method, variable, method, field, or class. In this case, it denotes that this is a method that should be run as a test. And this is part of what's called the JUnit framework. JUnit is kind of the de facto standard for implementing unit tests in Java. And so I've got this little piece of code that tests, well, my production code, tests my student class. And so what it does is it creates a new student object, and the name of the student is Pat. It's not taking any classes. The GPA is 0, and the gender is, sorry, hidden behind some screens, prices like doesn't matter or something, right? Yep, doesn't matter. So I create that, and I verify. I use this method called assert that. I want to say assert that when I call the getName method on Pat, that the value is equal to name. So this is a simple unit test that verifies that yes, my code does what it's meant to. And IntelliJ lets me run that unit test really easy from the IDE. Right now it's building the project, it's compiling all the code. It ran the test, and sure enough, yes, it passed. Let's see here, show ignored. There's a way to let me see, I can never remember what it is. Oh, there it is, great. Now I can see the names of all the methods that were run. So this is what's called a unit test, because it is testing one little unit of code, in this case, the getName method of my student object. So I want to do a quick poll. I'm going to clear everything from last time. How are people doing? Have people been able to get their environments up and running? Have people been able to open things up in IntelliJ? See one question from David. Yeah, go ahead.
Yeah, I didn't see how you ran that. I tried to run student and it said no test found in the package. So I just.
Oh, interesting.
I think I missed something right there. What you just did, like.
So let's see here. You did the Maven so sorry, you're back on the command line, or are you in IntelliJ?
IntelliJ.
So let's see here. Probably when you opened your project, did you open up the pom.xml file, or did you say that create project? Yeah, there's a very specific step.
I have the pom.xml file.
Mm-hmm.
But I'm sorry. What's the question?
Yep. When you so you open up the IntelliJ application, and you then then when you actually, let's see here. Let me start over with that. I don't think I'm really losing anything right here. I'll close this, and I'm going to blow away the IntelliJ files here. Let's see here. Find name, start IML. Is that what they are? Yeah, I'm just gonna blow those away. And there's a .idea directory. I'm going to blow that away. And there's not one in student though, right? Good. Okay. What I just did is I blew away all the IntelliJ files I created just now. Now, when I go back to IntelliJ, yeah, and this is something that yeah, to be really careful about. I should have highlighted and gone slower. So you're here in IntelliJ. Click Open. And I recommend that you navigate to the top level pom.xml. There's one here in the Portland State Java directory, and there's also one inside student. Open up the top level one. And so double click to open. And it's going to ask you, do you want to open it as a file or do you want to open it as a project? Open it as a project. if you don't, then IntelliJ doesn't analyze all of doesn't get your class path right, doesn't know about the dependencies, and it doesn't know necessarily which files and directories represent source code, which are test code, et cetera, et cetera.
I think I'm not understanding what opening as pom.xml instead of as the top level directory does.
What it does, so yep, good question. So the Getting Started repository contains multiple Maven projects. We've only seen one. We've only seen, actually, well, there's a top level project that has a child. Sorry, where is it? Oh, there you go, modules, which is the student. So what we're going to build over time is you're going to have multiple Maven projects. You're going to have one for student. You're going to have one for your project one. You're going to have one for your Koans. You'll get one later. But they all have this parent POM. And so what this allows you to do is have basically one big Uber Maven project that has these submodules. And so what I recommend is that in IntelliJ, you just work from that parent directory, and you'll see the submodules there.
Okay, I think that makes sense. I need to think about that a little bit more.
Yep. Yeah. So, yep. So go play with that for a little bit. Scott, you also had a question.
So I have a
sorry,
POM in student and a POM in the top level directory. You're saying open up the one in student or the one in the top level?
Top level directory.
Okay. When is the one in student used for?
That's there's a parent-child relationship, and the parent will have multiple children, and so the student needs to know how to build itself. So if you go and look, the pom.xml files are really quite different. The one at the parent, well, I kind of don't want to go into all these details now, but the one in the parent doesn't have anything about dependencies or anything like that. If we go and look at the POM in the student, it's got all sorts of stuff about like what build plugins to use, and it talks about reporting, et cetera, because the student is actually like a Java project where the parent one is it groups together multiple sub projects. This is kind of advanced to the first day, and so I don't necessarily need to go into it all. I think what's my goal for everyone today is just sort of get things working. And then we can talk later, especially after you've watched the Maven lecture. Things might make a little bit more sense.
Gotcha. And I'm sorry if this is too many questions. I'm trying to understand. Is there going to be a pom.xml for each assignment that we're going to create through a Maven package?
That you're going to create as a Maven project, yes.
Okay, yeah. And then those POMs will be available once we've initialized them, and then we'll be able to open them in our IDE.
Yep. And we're going to see two more of them tonight.
Okay, cool.
So yeah, so by
okay, now it all clicks. Gotcha.
Sometime in the next hour and a half, you too will have multiple sub projects in your repository. Good question. And this is what you see. And this is the experience of the first week of class. The first project's pretty easy, but really what people do during the first week of the course is just getting familiar with the environment.
Mm-hmm.
Thank you. Thanks. Yeah, Scott.
Yes, sir. So I'm having an issue here, and I sort of feel like I'm starting to make some headway, just going down the rabbit hole of Stack Overflow. But when I try to run the program in IntelliJ, whether it's student main or the test, it's giving me an error saying that it's an invalid source release. I'm not sure if I need to change something in my project structure when it comes to, the project SDK and the project modules and stuff like that. But that's kind of where I'm at. I can't run anything because something doesn't seem to be updated to the current version.
Okay. Well, that's interesting. Maybe
I'm not sure if that's something that goes outside the scope of this, or if I just need to spend some time on Stack.
You might not be the only person with this. What I recommend is that I don't know what platform you're on, but if you can go to the project. The project structure.
Mm-hmm.
And then you might want to look at the project SDK versus the project language level.
So the SDK is 14 and the language level is 9.
Oh, that should be okay. Huh. I'm not too sure then.
Okay.
And it's saying that the language level isn't.
Yeah,
isn't
the error
right?
message it's giving me is error Java invalid source release 10.
Well, where is it getting 10? And that should be an okay source release.
That was my prior release, but I updated everything in here to 14 yesterday.
Okay. I'm not sure. Sorry about that.
No worries.
Huh. Well, let us know what you find.
Yeah.
And if you're still struggling, like, day after tomorrow, well, and please reach out on Slack if either if you get it working or if you're still not able to figure it out.
You bet. Can do. Thanks.
Cool. Thanks. Okay. One other thing that I want to show you in IntelliJ. So IntelliJ has really great. Sorry, I gotta move things around here. Has really great support for version control. So up here under the VCS menu, excuse me. Oh, sorry. I guess it's already enabled. There's this version control panel here, which lets you know what files that you've changed in your repository. So remember what we were doing a little while ago with Git. We created this repository that had like all the changes from the getting started. It's now yours. It's your summer 2020 repository. And then we went and ran that create project 0 script. That created a bunch of files. And those files, well, it created a bunch of files and it changed one file. It changed the pom.xml at the top level. And then it added a bunch of files all right here. And so, it created a bunch of files on disk, but Git doesn't know anything about them because you haven't added them to your Git repository. Well, you can do that very easily from IntelliJ here by selecting them and right-clicking and saying Add to VCS for version control system. And now they're all here. And what you can also do from IntelliJ is then commit them to your GitHub repository. And so now I'm going to do that. I'm going to right click. I'm going to try to right click. There you go. I'm going to say commit. That brings up a dialog that says, hey, here are all the files that are changed that are about to be committed to GitHub. And I'm going to, sorry, move some of these windows around. It's driving me crazy. I'm going to put in a commit message. So added the beginnings of a, back again, of a student project. And so now what I'm going to do, I'm going to commit that. Actually, I'm going to say commit and push. So what this does, so Git, when you cloned your repository, you basically made a local copy of it. And you can commit changes to that local repository and let it stay there in the local repository. But the local repository is a clone of something on GitHub. So if you push it, that will take those changes that you made locally and push them up to GitHub. So if you say commit and push, it does some code analysis. It'll probably complain about some file it doesn't like. Yeah. I'll say, yep, it committed and push anyway. And it says, yep, you're going to push it up to origin, which means the GitHub, the version of your, no, the copy of the repository that lives on GitHub. That's origin. Yep, up to the master branch there. I'm going to push. And so IntelliJ is doing all this heavy lifting. So I mean, a number of you have probably used Git from the command line, or maybe you've used the what is it? The Git window explorer thing, Git Explorer, whatever that's called. Done things that way. I like to. Oops, looks like it missed a file. That was weird. I wonder why that didn't. Go up there. Commit. Oops, commit. And now I need to push it. Push it. And now everything is up there. So now IntelliJ, which has this integration with Git, is saying, hey, you know, there are no local changes, and we pushed everything up to Git, which means that if we go then to our repository in GitHub, and I refresh, it'll say, oh, look, I just made a commit 26 seconds ago, and interesting, it doesn't give me the Git interface has changed a little bit since the last time I used it. Now I guess if you go to this revision, it'll say, good, added the beginnings of a student project. So IntelliJ has really great integration with Git, and it makes it really easy to change a little bit of code, verify the test still runs, and then commit the changes. Look at the clock. It's 8:08. I think it's time for another break. Let's see here. It looks like the chat that's going around is people helping each other out. That's great. I really appreciate it. Let's take a 12-minute break. Hey. And let's come back at 8:20 and look at some more code. Okay. Oh, super nice. Okay. Okay. So before the break, we started looking at unit tests. And unit tests, like I was saying, they exercise a little piece of functionality. And unit testing really got people thinking about what testing is all about and what software quality is all about, and especially the internal quality of the software, making sure that your code works and works all the time. And so the best way to do that is to actually verify it, right? Is to write code that tests the the main code, the application code. And this led to the, I wouldn't say discovery, but people established the practice of test-driven development. And there's a video that I wanted to show you from someone named Bob Martin. He is a well-known software engineering, I think, luminary. I'm sure, yes, luminary might be the right word for it. This is a video clip from going full screen now. Really? There we go. This is wow. Is this my computer just kind of freezing? This is a video from a series that he has put together called Clean Code. And what he's going to do is he's going to walk through a test-driven development session, I guess. And I believe I am sharing my computer's audio. I'm going to turn it on. Actually, okay, let me get out of full screen mode. It's not going to make it any bigger. It's kind of lame. And I'm going to start the video. If you don't hear the audio, please either speak up or raise your hand or get my attention on Zoom.
Oh, it's time for the red-green refactor cycle. And
Oh, right. Uncle Bob is kind of an acquired taste, and he's a little wacky, but what he says is really good. So, oh, thanks for the sound being there. Okay. Anyway, back to the program.
I'm in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing.
I wanted to pause here. He used a term called refactoring. I don't know how many of you are familiar with that term, but the whole idea is that refactoring is where you take your code as it's currently written and you improve it in some way. Maybe you improve the variable names, maybe you look for duplicate code, maybe you rearrange your code to make it more readable, more performant, more easy to extend in the future. And so then in test-driven development, you go through these three phases. You have a failing test, you make it pass, you look for opportunities to improve it. And of course, you run the test again to make sure that still does what you thought it did.
Lovely. Back to the red face. The next test, well, I know I want to write that roll method. All right, test, can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll, what should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. Ooh, but I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes, and now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Of course, happy coding. So that's an introduction to test-driven development. I'm going to stop sharing my screen real quick, take off the computer sound and the video clip. What were some of the things that you noticed in that video in terms of how Uncle Bob went about testing? Just feel free to raise your hand and I'll call on you. Mark.
Wearing different hats.
Say more.
Different roles, like thinking contextually about that stage of that operation, not and just that siloed work habit.
That's right. He was very deliberate about how he approached test-driven development, right? He's like, okay, the first thing I'm going to do is I'm going to write a test that fails. Now, why do you think it was important to write a test that fails?
It's easiest to implement.
Yes, right. The code the code shouldn't exist yet, right? The intent is why it's test-driven development is that you write the test first so that the code, the main code, the application code, is only as complete as your tests. And that way, you know that you've tested all the functionality that's been implemented because you've only implemented functionality that's tested. Good. Someone else raised their hand, looks like they put it down. What are some other observations that people had about what Uncle Bob did? Yeah, Seth?
He started simple and increased complexity as he went.
Yes. That's another key to test-driven development, and this is hard as a programmer, right? I mean, I don't know about you, but boy, in my computer science 101 course, I'm like, haha, great, I'm writing code finally, and I'd put the entire solution together. I thought I had it 100%, and I tested it, and my God, it didn't work, and like, oh, where's the bug? And you spend hours and hours debugging. One of the things that I found about test-driven development is that, yeah, I mean, you are spending time up front coding, but that time that you spend writing those tests, pays back with interest over the lifetime of the application that you're writing because you're not debugging, right? As long as you can think of the test case, you write the test case and you see if it works. And when you start with that, it's much more likely that you get well into coding only to realize like, oh, there was some condition that you missed. And when there is, you just write a test for it and you figure it out that way. And of course, you've been developing this suite of tests. And so after you make a little bit of change, you run all of your tests to make sure that you haven't broken any functionality that used to work. Andrew, what are some of your observations?
Yeah, I noticed that he created tests knowing full well he was going to delete them.
Yeah, isn't that interesting? I don't know if he knew it at the time, but that's he points out one of the things you find is like you write a test, it makes sense, it's fit to purpose for a while, and then your code evolves beyond it. So maybe, it was originally a test, then becomes a no-op, or gets, moved into some other tests. Great. Sean.
Yeah, he followed kind of a pattern or circular routine, starting with like making the tests or writing a test that fails and then making sure the test pass and then refactoring.
Yep. Yeah, it's that red-green refactor cycle that helps you take these little baby steps towards the eventual solution. Excellent. Great, thank you for sharing those observations. So that, in a nutshell, is test-driven development. So now I want to take a few minutes and start writing some tests for the student class. Now, remember, ultimately, what we're looking for is that when you run the student class with this command line, it's going to spit out something that says something like this. Now, I want to start someplace. I think where I'm going to start is basically saying when I have a student whose name is Dave, that the toString method, and it's the toString, let's see here. Yeah, right. The main method prints out the value of the toString method of the student that's created. I want the toString contain the name of the student. So I'm going to implement that as follows. So toString contains student name. So I'm going to have a student name Pat, and I'm going to create, I'm going to use var there, string student, let's call it Pat, I guess, equals new student, and the name is going to be Pat, and I don't really care what classes the student takes or what their GPA is or whatever. I'm just going to have that. Oops, what doesn't it like? Oh, it's not a string, that's a student. See, IntelliJ is so nice. It tells you all these things are wrong. Oh, what's here? Oh, yeah, right. I didn't have a return type here. It's supposed to be a void method. Avoid. And now I want to say that, assert that the toString method, the result of the toString method contains string, oops, name. Contains string needs to be imported. And so I will statically import that from the Hamcrest library. So one of the things you learn about in the JUnit lecture is that there is this Java library called Hamcrest, which gives you what are called matchers. And it lets you write these nice assertion statements like this in Java that read pretty well. So you can say assert that some value contains the string that you're looking for. Alex, yes, or Alexander, sorry, yes.
Oh, yeah, I was just curious, like, how did you get up that option to import it by clicking on
Yes.
that function?
I used option enter. It's the magic thing here. Let me take out that import. And let's see here. Cannot resolve name. Shoot, what is the, I don't even know what the command is. It's option enter for me on the Mac. I think it's control return on Windows. I can't remember. And then it pops up this little like, help me fix this.
Oh, nice, cool.
And then, yep. And then I say import static method. And then I happen to know that I want this contain string from Hamcrest. And the nice thing about Hamcrest is that it gives you nicer error messages than plain old JUnit asserts that just tell you like, nope, this is false. This actually will tell you, well, actually we'll see in a second because it should fail. So I'll run the test again. And it'll build the project and it runs and sure enough, it's red. Oh, look at that. It says it threw an unsupported operation exception and it gives you the stack trace. And so I can just click on this right here to go to it. Oh, right. This does not contain what I want. This throws an unsupported operation exception. Okay, well now I got to make it pass. I don't have one of those fancy hats. And so let's see here. What do I want to do? Well, I want to say I want this to return this dot name. Actually, wait, there's a get name method? Oh, there is. Sweet. I'll just use that instead. Okay. And I think that'll work. Let me try it again.
Doesn't Java have a toString already built into all objects?
All objects have a default implementation of toString. That's a very good point. So what would happen if I didn't override this method? I'll just comment it out. It no longer overrides it. It now will inherit the default implementation of toString, and let's see what we get.
Yeah, I can
run my test again. Yep, it has an implementation. Oops. Oh, the toString method calls the says method, and says method blows up. So, okay. I will uncomment that. Actually, what does it say by default? It says hello. That's nice. Okay. Go back down. Gonna comment that out so things don't blow up. Oh, really? What? That's surprising. What is the value of toString? Oh, guess what I get to do? I get to run the debugger. Okay, yeah, a little advanced topic here for the first night, but heck, let's do it. So I was surprised that this test passed. I did not expect toString to contain. Oh, but look at that. It does call get name. So that's super lame. So it didn't do what I expected. You're right. I didn't realize that toString, the toString from animal, sorry, I'm going too fast. I'm going to back up. Okay. Student. Let's go to the student class. Student extends human. Now, human, the source code for it is not part of the project. This is code that comes from a library that I publish separately. But because of the information in the Maven project, IntelliJ is able to find the source code that I published and let you navigate to it. So when I hold down the command on Windows, it's Control on Windows, and then I mouse over it, I can click on human to go to the human class, and because it's download the source code. So even though this code isn't part of the project, this code comes from, actually, if you can read up here in my title bar, it's from this example summer 2020-source.jar, right? IntelliJ can still see it. Human extends mammal, which extends animal. And animal is the one that provides the toString method. And the toString method calls getName, which is this .name, because that's interesting. Animals, I guess, don't have a constructor that initializes name, but somebody else does. Oops, there's a whole bunch of other subclasses there. And then it calls the says method. And as we saw, it was blowing up before because says threw that exception. So, but what I was trying to show here is that the default implementation of toString, the one inherited from object, actually we can even go look at that. Here's Java lang object. It calls all sorts of crazy stuff, including like the hash code and the class name and et cetera, et cetera. It would not have included the name of the animal, or sorry, of the student. But because of the methods that had overridden, because sorry, let me close this one. Gotta close this window. Got too much stuff open. Because animal overrode toString to call getName, it actually did include the name. Kristen asks, how do you see the code? I'm just getting info about stuff that exists. Sorry, I can't see this off screen. That exists, but not the code. I think IntelliJ. Let's see here. For yes, yeah, you have to hold down Control and click. But I think, Kristen, did you already do that? Hold down Control to get highlight over it. You can come off mute if you'd like. It's a pretty important question.
Okay, so I was gonna look at human in the student.
Yeah.
So just Control click, you said?
Yep, on Windows.
Oh no, I'm on a Mac.
Okay, then Command click.
Oh, okay.
I almost said Open Apple click, but no.
Oh, okay, there we go. Thank you.
Awesome, cool, good. Glad it worked for you. Anyway, okay, well, actually, so we have a passing test. Isn't that interesting? Well, passing test is good. So, you know what I'm going to do? I'm going to rerun all of my student tests. And everything passes. So that's kind of neat. I'm going to call this good. I'm going to check in these changes. Now, I like to work in really small chunks. I like to write one unit test, get it working, and then check it in. Actually, before I check it in, I'm going to refactor because I bet there's some stuff that could be refactored. I was copying some code. So look at this. I've got this new student. I've got exactly the same call here. I'm going to refactor this into a method that calls this code. Now, like I said, refactoring is taking code and making it cleaner, and there are these particular refactorings that you can do and are supported by IntelliJ. So if I go and I hide a bunch of code and I say refactor and I say extract method, what this will do is it'll take the highlighted code and say, great, I'm going to go put that in a method. And I am going to call this create student named. And there it is. It's going to tell me, okay, here's what the signature is going to look like. It's going to be a method called create student name, return a student, takes a name. That sounds pretty good. Oh, look at that. And it says one duplicate code fragment can be replaced with extracted method call. Thanks, IntelliJ. And you click refactor. And so it's gone and create this method called, create student named down here, and it's found this other piece of code, which says, hey, wait, this is that same piece of code. Do you want to refactor that also? I do, so I'll click replace. And there you go. We've taken some duplicate code, refactored it into a method. I'm going to move this up a little bit. See, what do? You do that. Yep. There you go. I just like my methods at the top. I don't know why. It's probably some old C programming code thing I learned a long time ago. Now, I've made some changes to my code. It shouldn't make any differences, but you know what? I have unit tests. So I'm going to go back and run my tests again, my entire suite of tests, just to make sure that everything works now that I've changed my code. And for me, this is the real power of unit tests. You develop this whole suite of tests that basically are the safety net. And so that you can go real fast, you can make lots of changes, and if you broke anything, you find out almost immediately that you broken something, instead of having to like make a bunch of changes only to find out that something you wrote 2 weeks ago completely messed up your entire system, but you just hadn't discovered it yet. Okay. Everything's passing, so now I'm going to check these into version control. I'm going to say commit. I'm going to say added unit test for ensuring the name of the student is in the toString method. That was in the toString. And I'm going to then commit this and push it up to GitHub. Okay, well, that probably wasn't the world's most interesting unit test. Let's go find another test that we can implement. So let's see here. Oh, okay, good question from Evan. Should unit tests cover the main methods inside inside classes? Yes, we will talk more about that next week when we talk about integration tests. They're not exactly unit tests, but what we're going to see is there's another kind of tests that will exercise our main method and let you handle things the main method does, like write to standard output and call system.exit. And it was actually, and way earlier on in class, someone asked another really great question about unit testing and sort of like, hey, does anybody do this for real? And what happens when there's a deadline? Boy, I've got a whole rant about that. And I want to save that for next week, though. Next week, we're going to talk about your projects and the code coverage requirements for your projects. And that's where I think we're going to get into some real world questions about unit testing. Plus, it's getting late. Okay. I think the next thing I want to do is I want to, let's do the GPA. Let's make sure that the toString has the GPA. And this should make things a little bit interesting. So I'll go back here and I'll say the following. I'll have another test, public void toString contains GPA. Okay, so now I want the student, and I'll call them, I don't care, it's Pat again. And now I want, I'll just, you know what, well, let's see here. I'll just say new student, and then Pat, and then no classes, array list, empty, and then that's what the GPA is. So the GPA, we'll just call it 3.76, and then gender doesn't matter. Okay, and I want to assert that pat.toString contains string 3.76. Okay, and now I'm going to run this. I'm going to start using the keyboard shortcuts. Now I have this magical plugin to IntelliJ that does these little pop-ups when I use keyboard shortcuts. I do that so that you can see what the keyboard shortcuts are. I'm a big fan. So for me, typing is much faster than using the mouse. Maybe it was all those years of piano lessons. Thanks, Mom and Dad. But I can type way faster than I can use the mouse. And so for me, a big key to my personal productivity is using the keyboard shortcuts. Not everybody's like that. There are a lot of people that are very fast with the mouse, that it sort of matches their brain. For me, I have to use my fingers. My fingers and my mouth. I talk a lot. Anyway, so I ran this, and now, this is now failing with a nice assertion error, saying, hey, I expected a string that contained 3.76, but what I got was Pat says hello. And that's what the toString method will return right now. Okay, let's go and fix this. Oh, and look, IntelliJ even underlines it in a dashed red saying, hey, this was the assertion that failed. Intelligence is really smart like that, right? It just sort of, I don't know, it's intuitive. I really like it. I think it's a good tool. Helps me do my job really well. Okay, well now I want to go implement the toString method here, and oh right, this took me to the toString in human or something like animal, I guess. I don't want this one. Instead, I guess I want to override toString in student again. Okay. Oh look, I even done this dot name. And oh, you know what? My test is wrong. I don't want to just say that contains 3.76. I want to say has a GPA of 3.76. There you go. This is still gonna blow up, right? Yep, because all it says is Pat, which is all it's doing right now. Okay. So now I want to say that has a GPA of this dot GPA. GPS. So this is a reference to the instance object in which this method is invoked, the object in which this method is invoked. I want to add a field. So now I use my magical alt return and says, hey, create a field. Yes, I want to create a field. The GPA is a double, right? A double is a 64-bit floating number in Java. And it's highlighting in gray because it's saying that, aha, the field is never assigned. That is true. I'm going to assign it here in the constructor. I'm going to say this dot GPA equals GPA. Okay, so now when I create the student, I'm going to assign the GPA to that field. I am going to print it out here. I think it's time to run my test again. Let's see what happens. Hey, it passed. Pretty sweet. Okay, let's go through and run all my other tests now. Yes, all my other tests pass. Great. Okay, let's look for an opportunity to refactor. Let's go back to the student test. Let's navigate. Let's jump to the source. Let's see here. I'm creating a student here. I'm creating a student up in the create student named method. Let's get rid of this. Oh, there's some duplicate stuff. This value is also duplicated here. But you know what? I think that's okay. Well, actually, you know what? No, I don't like this. I want to pull this into a variable. So I'm going to use another refactoring. I'm going to say refactor, extract variable, and it's going to call it GPA. Hey, wow, that's neat. And then I'm going to use it here also. And then I'm going to run the test again. Yep, it's happy. You know, just for good measure, I'm going to run all the tests just to make sure. It's nice and cheap. Good. Okay. Yay, some more test-driven development. So now, let's see here. Store the GPA in a field. Well, cool. Well, I'm well on my way to implementing my student class. I think I've picked out the first couple of things that have been pretty easy. I can sort of imagine where I would go from here, but I'm looking at the clock and it's almost 9 p.m. And there's a couple other things that I want to touch on in class tonight. And so we're going to pick this up again next week. We'll do some more test-driven development. We'll see some more unit testing next time. But there are two important things that I want to be sure to touch on tonight, and that is the first two assignments in the class. So I'm going to close out this guy, and I'm going to go back here. Now, I am going to, let's see here. Sarah asked, do you archive the chat log? You know what I was thinking about doing yes, I'm going to archive it, and I think it downloads it to my local machine. And then what I'll do is I will upload it to, I don't know, should I create a special channel? I think I might create a special channel on Slack just for just for recordings, just for I don't know what I'm going to call it, probably call it recordings or something like that. That's where I'll post the YouTube link to the uploaded video, and then I'll also put up the chat log because yeah, lots of good stuff is going by. Also, when do you typically add the lectures to YouTube? I'll try to do it as soon as possible. With Zoom, I used to use Camtasia to actually record the screen, so like I had a lot of control over it. I don't know how long it takes Zoom to make the recordings available, so I'll try to do it within the next 24 hours. Okay. A few hours is what Max says. Thanks. Okay. So let's take a look at project one. So we talked about the student class, and project one isn't really all that different. So the oh, Max thinks might be a day. I don't know. Zoom record meetings are added to D2L under people's Zoom meetings, previous meetings. Oh, I didn't know that. Okay. But it's D2L. I try to avoid as much as I can. So this term in your multi-phase project, you'll be modeling a phone bill. And in this first project, you're going to build the fundamental application classes for that phone bill. So there's a class called phone bill that contains multiple phone calls. And this is a pretty straightforward project, but the whole goal here is to work with code that you didn't write. So you're going to be working with some of my code, and then you're going to be parsing the command line. So we're going to create the project, and when you create the project, there will I wrote some code off in my package. So I have a package, and remember, Java packages are just a namespace for classes. I have a package called edu.pdx.cs410j, which contains two abstract classes called abstract phone bill and abstract phone call. And what you're going to do in this class is you're going to extend each of those classes for your own phone bill, which extends abstract phone bill, and your own phone call, which extends abstract phone call. And these are concrete classes, so they must implement all of the abstract methods of its superclasses. As we'll see in a moment, each phone bill has a name of the customer and consists of multiple phone calls that customer made. A phone call is created is initiated by one person, the caller, that has a phone number at a given time, and is received by a callee, a person with a different phone number, and then the call terminates at a given time. Now, for this assignment, you'll be representing all data, especially the or in particular the start and end dates as certain times as strings. Yes, some of you might be familiar with classes like Java util date for representing dates. You can use those if you want, but that's not required here in this first project. So if here again, all we're doing is working with strings. In addition to your phone call and phone bill classes, there's also a project one class that contains a main method, and this is what drives the usage of the phone bill and the phone call. The main method parses the command line and creates a phone bill for the customer whose name is given on the command line, and also creates a phone call with the additional command line arguments, and adds that phone call to the phone bill. It also optionally prints a description of the phone call by invoking the toString method of the phone call. And here's what here's what the command line interface looks like. You run your program, it'll be through the executable jar. Which is essentially going to run your project one main, and it's got some options and it's got some arguments. The options precede the arguments, but the arguments are customer, caller, caller number, callee number, the start time, and the end time, which is a date and time in 24-hour time. I'll give some examples later. And then there are also these two options, the print option and the README option. The README option we'll talk more about in detail next week. You can read ahead to the documentation or to how to document your code handout, but we'll talk more about it in detail next week. The print option will print the description of the README by invoking its description of the phone call by invoking the toString method. And the format for the dates of time is a 2-digit month, day, and year, and then a 2-digit 24-hour, hour, and minute. So do I give an example? I don't give an example. I probably should. But anyway, if you have something like a multi-word customer name on the command line, those should be in double quotes because it's only one command line argument. Dates and times, however, are multiple arguments, or 2 arguments. So there's a command line argument for the date and a command line argument for the time. And okay, so misspoke. It's up to 2 digits of the month. So a 1 is the same is valid as is a 01. And note that the phone numbers have the form 3 digits dash 3 digits dash 4 digits, where again n is a number between 0 and 9. There's also something called a POA, or a plan of attack. I'll also cover that next week. But you can read ahead in the handouts for next week. Lots of footnotes here in terms of how the assignment works. Note about error handling. I'm going to be honest with you. Most of the logic in this first project, and honestly, what you'll be tested on, because there's not a lot of happy path stuff here. You just read parse the command line, and if the dash print option is present, print out the 2 string. Most of what you'll be doing is error handling. And so then your program should exit gracefully. So this is like a nice user-friendly error message. Not a stack trace, not core dump. We're not going to have that in Java. When the data provided by the user isn't correct. So maybe something's missing the command line, or we have extra command line arguments, or the date or time is malformed, or the phone number contains the wrong number of characters, or things that aren't numbers, things like that. I'll also cover next week how to submit the program. This project isn't due for another 2 weeks. The whole idea is that you're getting your feet wet with Java during this first week. Before I go on and talk more about how to create the source code, any questions about what the project does or how the project works? Yes, Kristen?
So I was just wondering, did you say that you said what the phone number format was? Is that also a string though?
It is, yes. It's a string. So this will come in as characters on the command line. It'll be in that string array args that are passed to your main method. And yes, you'll model it as a string throughout the entire program. Seth?
So if no options are given, it's just going to exit after the...
It should print an error message and say, hey, no options, and then exit.
Oh, so it needs one option.
Yes, there's not a valid command line that can... Oh, I'm sorry, options. Sorry, I thought you meant arguments. You were correct. I was wrong. If all you specify is the customer, caller, callee, start, and end, it reads it in, it validates the command line, and the user doesn't see anything, right? The only way the user sees something is with the dash print. So to be clear, you don't save anything about what's entered on the command line. There's no persistence from run to run. This is just project 1, right? Don't worry. Look ahead to project 2. You'll be writing stuff to files. That's next week. For this week, the goal is to start getting writing with Java, start writing some unit tests, and doing some very fundamental things. Don't worry, things will get harder in the future. Sorry, more challenging in the future. Good questions. And I'm sure there'll be more during the week. As a matter of fact, since I'm all here, I created a Project 1 channel in Slack to talk about Project 1. I prefer, I think it'll be easier for everybody if things that are specific to the projects are in these channels as opposed to putting everything in general. It makes it really hard to go back and find things, or hey, if you're working ahead, you're already on project 2 and other people are still on project 1, that way it won't confuse everybody.
And what's the official name of the Slack for this class?
It's Portland State Java Summer 2020, I think. Did I give you an invitation URL?
That have been through email?
It did, and I posted it in the chat a couple times tonight. I'm happy to post it again.
Oh, okay, that's probably me just not seeing it.
That's all right. once more with feeling. Share the invite link. It's easy. It's 3 clicks away. And a copy and a paste. Okay. Now, to help you get started, there's a Create Project 1 script, which is very similar to the Create Project 0. So back here in our repository, there is a Create Project 1, and you give it your user ID. Basically does almost the same thing as the Project 0. Okay. Now I will go back to my IntelliJ, and I will click or refresh. And now I've got, in addition to student, I've got a phone bill project, and yet it doesn't. I wonder if I need to refresh my synchronize. Interesting. Does it recognize it as a? It does not. Oh, isn't that weird? Oh wait, now I know why. Sorry. Down here in the bottom right, it's saying, "Hey, we've noticed some changes to your Maven project." What I did was I created a new phone bill directory, which itself is a Maven project. There's a new child project, and IntelliJ is like, "Hey, wait, I saw that you did this thing. Do you want to import the changes to your Maven?" Yes, I do. So I click import, and now it treats it as a project, and so now it's got source code in it, which is good. So let's take a look at some of that source code. How do we do that manually? You'd wait for IntelliJ to pop it up. And if somehow you mess it up, then you have to blow away all your IntelliJ files and start over again. Not a big deal. And I think I talk about that in the getting started, because I've IntelliJ. Oh, here again. Yeah, right. If you do not build an Maven project first, and your IDE will not be very happy. So delete the IML files and the IDEA directory associated with the Maven project and start over again. And then you open up the pom.xml as a project again. And don't worry if that happens to you. It's a common mistake. This is tricky, right? And here again, I've been doing this for so long that hey, I remember back when it was much harder to do this in IntelliJ. And this is just sorry, I'm going to go on a little tangent here. This is one of the things that I've learned by teaching others. One of the things that I find really beneficial about teaching at PSU. It's really helped me understand not only the beginner mindset, but give me an appreciation of everything that I've learned over my career, and why there are some things that just sort of seem natural to me. And then when I talk to my students, it's like, oh right, they didn't have to solve that problem 20 years ago like I did, or hey, they haven't seen the progression of something like version control. And so then I find myself, sometimes with coworkers too, where they're like, I don't understand why that new person doesn't understand this. It's like, but wait, you've been doing this for 15 or 25 years. There was a point where you didn't know that, and you learned it, and then you used it every day since then. It's like, how can we, as more experienced people, better get the people who aren't as experienced or have different experience up to the same level as we are as quickly as we can, because it benefits everybody. So anyway, sorry, I don't. And so then it's notes like this that I've taken over the years to help you all just get up to speed quicker. Let's see here. So Scott asked, so building project 1 in the terminal should cause IntelliJ to give me a pop-up for synchronizing the files, or did I miss it? Yeah, I think it should. Maybe what you need to do though is click like the synchronize. So either the refresh VCS changes over here, or go to the file menu and hit synchronize. Because you change things on the file system, IntelliJ doesn't necessarily pick it up. But if you tell IntelliJ, hey, go synchronize with the file system, that'll work. Yeah, synchronize didn't work. Why not automatically? I wanted to add new files to Git. Yep, there's that too. Okay, well, sorry, Scott. Maybe that'll try poking around a little bit, but maybe you'll have to recreate your IntelliJ files by following these instructions here on the Getting Started repository. Okay. Okay, cool. Now I got phone bill. Let's take a look at some of the code in the phone bill, project. Actually, I've got a whole bunch of stuff here. I'm gonna add it from the command line just to show you. So if you say get status, get add pom.xml and phone bill, get status, all this stuff. I'm just gonna commit it here from the command line. Added files for project 1. Okay, and so that committed them all to the local repository, and I'm going to push. I'm doing the same things in the command line that I did in IntelliJ. Sweet. Now I go back to IntelliJ, and I got to refresh again, and it'll say, hey, look, no changes. Good. So out of the box, what's created is the phone call class. Phone call extends abstract phone call. This is one of my classes. And here again, this is all stubbed out, right? So it's throwing an unsupported operation exceptions, saying, hey, this method hasn't been implemented yet, et cetera, et cetera. I've got a project 1 class, which just goes through, I guess, and prints out missing command line arguments, and I guess goes and iterates over them. Oh, and actually, I should probably show you the Maven stuff too. So if I go into the phone bill directory, and I say, I probably got chmod the Maven W, and then I say Maven W verify, goes and downloads all the Maven stuff, runs everything. And now if I say java-jar target phone bill summer 2020.java.jar, that'll run the main method. It's in the command lines 1, 2, 3. Cool, it prints all that stuff. And so this project 1, it has unit tests here in the test directory. Here's a phone call. Some pretty straightforward things. Just sort of to get you started. As you get started on the project, I think one thing to sorry, let me go back to the project assignment again. All of this stuff is here. Right. Oh, we'll talk about Maven site next time when we talk about JavaDoc. But that's how you work with it. So one thing, I realize I don't mention the assignment, that's pretty important, is that, and we'll go into details next time, is that part of your grade, is determined by the amount of code coverage that your unit tests provide. And so then for this class, you are required to write unit tests. You can go read the testing handout from next time, but I strongly encourage you to start doing TDD for your project. Think about how to do it, play around with it, and we'll see more details about it next time. Okay. I think that's everything I wanted to cover for project 1. Do I have code coverage measuring tool? You bet I do. We'll talk about it next time. Okay. Project 1 is due in 2 weeks, July 8th, and it's before class. Any questions on project 1? I know there was a lot. Yes, Mark?
Yeah, so just in terms of trying to, stay on track or keep up the pace, since we're going to be covering some more of this project next week, what would you suggest that we get completed between now and then with what we've been given?
Let's see here. Probably, those unit tests I was trying to write for the student class, maybe something like that, where, hey, write the constructor for your phone call, and write some unit tests that maybe do some validation, some data validation, making sure that you can handle, phone calls in the right format. Sorry, phone numbers in the right format, and dates in the right format. I think that's where I would start, and I think those seem like really good really good places to start with test-driven development, right? Because that's where all the edge cases are. Oh, what if you have the wrong number of digits in your phone number? Or hey, what if it doesn't contain digits, or your date's malformed? I think that would be a good place to start. So probably with the logic for validating dates and phone numbers. Good question. Okay, one other thing, but wait, there's more. Now, I don't focus much on the Java programming language in terms of like what we cover. I'm not going to lecture you on all of the syntax and you know, and the newer stuff like lambda expressions. You know, that's there are lectures for that, but that's not what we're going to spend our time in class to do. But yet, it's something that you should know. And there's a lot of you know, there's a lot of behavior in the Java programming language to understand. And so I use what are called the Java Koans to help you, to give you an opportunity to explore sometimes the darker corners of the Java programming language and some of the Java libraries. So a koan is this teaching question in Buddhist discourse, and it's, you know, hey, it's meant to be, you know, the guru on the mountain, and they're asking you the sound of one hand clapping or something like that. These aren't that that ambitious. Instead, what they are is a series of little, well, programming snippets that look a lot like unit tests, where you learn about some aspect of the Java programming language. So, you know, how strings work, how Booleans work, how some of the collections work, things like that. And these are not mine. These come from this guy, Matty B, who's been working on these for a long time. And as new features are added to the language, he and his and the other contributors to that repository will add new koans. So this is another thing that's available to you in the Getting Started repository. And so now I'm going to say create koans and my ID. And let's go ahead and yeah, change maybe, yeah, that. So get add pom.xml and koans. That's all very nice. Get status. Yep. Added koans. And then I'm going to say get commit made maven w script executable. That's what changed. Push all that to GitHub. Sweet. Now let's go back to IntelliJ, synchronize things again. I think it'll tell me, hey, there's a new Maven project in town. Please, actually, I'll enable auto import. That sounds nice. Now I've got these things called koans. That's cool. Now, the koans you run a little differently. What you do is you run a Java program that prompts you to go off and do the koans. And you have that running in the background while you're working on them. So we go into the koans directory and we say Java exec. Sorry, you say Maven. Oh, I didn't make the Maven. I need to do the chmod again. Oops. Now I say Maven w exec Java, which runs a Java program. That's correct. Okay, so it's running this program, and it says, "Hey, welcome to the koans. Open up this aboutkoans.java. There should be a method starting with @koan called findaboutkoans file. Look within it for your first lesson. Once you have solved that, save the file and check back here for your next lesson." Okay. So IntelliJ, I am going to let's see here. How do you even find that? How do you do open file here? Sorry. All I know is that's Command Shift N, and you say about koans. Okay, let's take a look at this. It looks a lot like a unit test, but now they're @koans instead of @tests. So find about koans file. Oh yeah, and if we go back and look at the command line, it's saying ponder what's wrong in the about koans classes find about koans file method. Line 11 may offer a clue as to how you may progress. Now make haste. Okay. Yes, sensei. No. Find about Koans file calls the fail method with some text says delete this line to advance. Well, what should we do? Let's delete that line to advance. Now, IntelliJ will automatically save the file when I navigate away from it. So now when I go back to the terminal, the program that's running here will detect that the file has changed and it runs it. And like, great, it says, I have accomplished 1 out of 269 Koans. Okay. Now it's considered complete when it no longer throws an exception. Often there's more than one way to solve a Koan, but only one correct way. This has been hinted at within the Koan itself or the comments appearing here. So then ponder what's going wrong on definition of Koan completion method. Okay, let's go back and look. Okay, so let's see here. Koan is complete equals false. If not false, fail. So then we don't want this thing to fail. So what should we do? Let's set this to true. Now when we go back, reloads it. Hey, that helped us pass on. Now we have 2 out of 269. Okay, now where it says about Koans is passing, so both of those are passing. Now it's let's see here. The underbar are an attempt to communicate the need to fill in an answer. Judging by context, what should underbar be replaced with? So now let's look at the about assertion classes. Assert Boolean true. So now let's open up about assertions. Okay, so the Koans library has this method like assert true, and right now it's looking for a value. So what should we put there? Well, assert that true is true. Yes. Let's see here. Okay, that passed. Yay. And so anyway, so the idea here is that we go along, and each one of these Koans gives you a little lesson in the Java programming language, a micro lesson, if you will. And let's see here, did we get the false one right? Yes, we did. And so then it starts out really easy, right? And anybody who's seen Java before will probably whiz through the first couple ones, but it gets more interesting and more challenging and insightful as you go on. So here, okay, we're looking at a null reference. It's a magic keyword, also known as a keyword. There's no magic there, really. Yep. And here we are going about our merry way. As you can see, there are a number of suites, and actually there are 269 of these, which is a lot. All about things about, hey, how equality works, how arithmetic operations work, loops and conditionals and primitives. Again, if you've seen Java before, yep, most of it is probably straightforward. You might learn a couple of things. The number ones are always interesting because they have some things like floating point numbers and how automatic casting works, and upcasting, not upcasting, but like auto promotion from like a int to a double and things like that. So there are a bunch of these, and these are all in the Koans assignment. So this is an assignment that you do over the first half of the course, really. So this is due July 22nd, which is 4 weeks, 5 weeks, 4 weeks from now. And what I hope that you'll do is just do a couple of these every day. Kind of a slow and steady progress. You'll get more experience with the Java programming language, working with the syntax of the language, some of the libraries, some of the you'll learn sort of how object method overloading and overriding work. All sorts of good things. I found that's a pretty effective teaching tool. 269 of them, 10 a day is needed to complete by July 22nd. Yes. But I mean, some of them are really easy. But yes, the intent here is that this is done in parallel with the other projects to then give you a good background in the Java programming language.
Sorry, is this required?
Yes, this is due. Yep, this is due on the 22nd. And as a matter of fact, the 22nd. Okay, that's week 5, so it's halfway through the course. Yeah, actually, week 5 is kind of a monster. There's a lot of stuff due in week 5. So this is like started early, As a matter of fact, do a little bit of project 1 this week, and then probably want to focus on the cones. Getting, I found in the past students that get a head start on the cones tend to do better in the course, because not only are they ahead on the classwork, but they've also then gotten a much better feeling for the Java programming language and what it's all about.
How are they graded and submitted?
We'll talk about submitting next time. Actually, it tells you there's a program that you run to submit. So all the projects, I'm, with 60 students, I can't have the graders look at your code. And so then what you're ultimately assessed on is the functionality of your projects. And so the way I grade the projects is that I have scripts that grade them. I build all the code. I send command line arguments to your main method, and then I capture the output, and the script captures the output, and then the graders assess the quality of your output and assign a grade accordingly. And so then functionality is most important for these projects. For the cones, it's kind of an all or nothing. Either they all pass or they don't. And so then the whole idea is that you get to the end, or rather, you get as far as you get, and then your grade is dependent on that. Honestly, most people get full credit for the cones because they get them all to pass. Okay. I believe that's all the content that I had for tonight. Yes. And we covered a lot. So we talked about the course in general, in the big, all the stuff that we're going to cover. We're going to start with Java programming language, go all the way through Android. Thank you for doing that exercise with the helping me understand how I can be more effective delivering this class 100% remotely, and also helping me get some more experience with breakout rooms and how best to leverage them. Then we started looking at some code, and we saw the Getting Started repository. We saw how we can use GitHub to get off to a good start, and then also as you're working on your code, be able to save it to GitHub. Next time we'll look at how you can get, and actually it's in the description of the Getting Started repository, how you can then make a checkout of your code on the PSU machines and run it there before submitting. We looked at test-driven development. We watched a cheesy video from Uncle Bob that I hope at least drove home the points of how one goes about doing test-driven development. We'll talk more next week about unit testing and code coverage and integration testing too. And then we saw the Java projects in Maven, right? You use the create scripts to create that simple student project, which we'll use for me doing some coding in front of you to provide examples of test-driven development. And then we created our projects for project 1, the beginning of the phone bill application, and the cones project. And that's a lot for the first night. We used all 4 hours. That's not unusual, but I'm pretty done. But before we adjourn, are there any final questions about what you've seen tonight? Please raise your hand. Yes, David.
Yeah, I'm sorry. I came into the class like a little bit late. I couldn't find the Zoom link, but what do the quizzes cover? If you could just talk about that for a second.
The quizzes cover, well, the quizzes are related to the lecture content, which is related to the assignments. So this first one is all about your programming background, so because right, you haven't covered anything yet. But then it's basically like, hey, the concepts that were introduced the week before, at the end of the week, or during that week, there's a quiz. So I believe, let's see here, like quiz 2, I'm pretty sure is sort of like core language concepts, primary language concepts. But the intent is that the quizzes are about the lecture content, which is reinforced by the projects. Mark?
So to study for them,
sorry.
it's just you just pay attention, and is that what you're expecting?
Yeah. I mean, watch the lectures, understand the content, right? Do the projects, and work on the projects, and then that ought to give you the background for the quizzes.
Great.
Mark?
So yeah, just a kind of a follow-on question then. So since our first question or quiz is due next Wednesday, and it'll be administered through DTL, are you also going to be leveraging the D2L like announcements or notifications like you got a quiz due, or should we follow this schedule that we see here? And
Yeah, I'm not. I didn't realize D2L had that. I use D2L for administering the quizzes, not for managing the class. I mean, I think that as some of you noticed, it's kind of clunky, and you know, I'll write my own like little HTML. Thank you very much. So yeah, now that being said, yeah, you know, I have some students every term who are like, oh, I completely forgot about the quiz. You have a quiz almost every week, so you know, please check on D2L. And you know, do what you need to do to make sure that you know these things. So if that means like, hey, take, you know, 20 minutes now or tomorrow to, like, I don't know, set a calendar reminders for yourself, or you know, get them tattooed on your arm. I don't know what you need to do, but you know, it's worth a little bit of time to make sure that you're on top of things, because you know, yeah, I think as maybe the subtext for these questions, like, there's a lot of work in this course, and yeah, you're right, because you know, we want to cover a lot of ground. We don't have a lot of chance to do it, but it lets us get to the really cool, exciting stuff like REST APIs and Android in an 11-week class. No, sorry, in an 8-week class. Jeez.
thank you. So
Yep.
so when will quiz 1 be available for us to be in taking?
Should be available now, I think.
Okay, all right, thank you.
Yeah, I hope so. If it's not, let me know and I'll make it available. It probably opened up at the beginning of class tonight. Okay. Anything else for tonight? Okay. Well, hear nothing. Thank you all very much once again. I'm really looking forward to this term. I think it'll be, you know, lots of neat opportunities for us to learn together, and some pretty unique challenges, everybody being remote. So please join the Slack group if you haven't. Fill out the run the survey program to make sure that you can run Java on the PSU Linux machines. Start in on the Koans and Project One, and ask the questions that you have on Slack. I will see you next week. Bye now.
Yeah.